Hello, hello. Hello. Yes, hello everyone. Welcome on YourPedia platform. I hope you are fine. Guys, I am Vishal Sharma and today I am here in front of you with one of the previous year paper related to Telangana State Public Service Commission, guys. So total 150 technical question we are going to solve from various engineering subjects of mechanical engineering. And guys, let me tell you, these 150 questions are actually unique. Okay, this paper is actually unique. If you, this paper we have shared in various WhatsApp group also, you can check. Other than that, you can download this paper from the chat box. You will find some tag comment here in the chat box, and if you will click on that, you will be easily able to download this particular paper. Okay, previous year paper related to Telangana State Public Service Commission, guys, and there are very good questions asked in that particular examination, guys. So if you are preparing for any of the competitive examination like HPCL, BHEL, Oil India, or kind of state PSU, whether it is Jammu Kashmir Public Service Commission or Punjab Public Service Commission or anything, guys, this paper is going to help you because through these 150 questions which are there in front of you from different subjects of mechanical engineering, so through these 150 questions you will be able to revise the entire curriculum syllabus. Okay, so I will try to cover the maximum theory part which is possible, but there is a limit because 150 questions, if you will we will go into much more theory part, then it is going to take more than 7-8 hours and even more than that. So some minimum theory part which is actually required so that you will get idea, that I'm going to cover. So even if you are having some fundamental idea, or even you are not having fundamental idea, or you have not revised the various subjects of mechanical engineering, then also this class is going to be beneficial for you. You can attend this session. And guys, let me tell you, you need not to wait for the day to come, like when you will say, yes sir, now I revised all the subject of mechanical engineering and now I'm ready to solve the practice, now I'm ready to solve the various practice question. That day is never going to come, guys. So don't wait for that. From the day one, you need to start practicing more and more question. Okay, definitely when you are practicing more and more questions, some day will come you will get that level, you will get that confidence, all different questions will become easy for you. Okay, so guys, don't wait for the theory to cover. Okay, you need to cover the theory with some kind of questions. That kind of smart work you need to do in the today's very competitive environment. Okay, so you cannot spend 6 months, 1 year in just discussing about theory only. From the day one, you need to start practicing more and more questions. That's why I'm here in front of you with 150 questions related to the mechanical engineering, various engineering subjects. So questions are there from engineering mechanics, strength of material, all different subjects. Okay, so now let me put it here, guys. Question number 1 in front of you. So actually the paper, the original paper is there. Original paper you can download simply by going into the chat box. If you will click on the chat box, you will find some chat message there and you will be able to download that original paper. But here, because I am keeping some space, some editing is there in the paper, so that I will be able to write in between the two questions. Okay, so this is not the original paper. Original paper you can download, but all questions are original from that particular paper only. But just to keep some kind of space between the questions so that I will be able to write, so that's why here you will find some space between the questions. Okay, so guys, let me move here the question number 1. Now the session is going to start and you need to try, to practice with me, guys. Okay, so it's my request to all of you, please try to respond. Okay, आपको respond जरूर करना है, because here in this session there is no negative marking. There is nothing, there is not a thing like negative. Okay, only always you need to be a kind of positive person. So guys, you need to practice, you need to answering. Okay, whether your answer may be right or wrong, you don't need to worry about that, because in this session you need to practice, you need to try each and every question. So this was question number 1 in front of you, guys. If the resultant of two equal forces has the same magnitude as either of the forces, question is very simple. See, Vishwas is saying C. Vishwas, C is not right. Please first read the question. What is saying? The resultant of two forces. What is resultant? Resultant is equal to under root P square plus Q square plus 2PQ cos theta, where P and Q are the forces and two forces, and R is the resultant of these two forces, and theta is the angle between P and Q. Okay, so here what he is saying, He is saying resultant is equal to either of the forces, means resultant equal to P and it is equal to Q. Now if you will go with that, taking square both the side, resultant square equal to R square plus 2R square cos theta. Okay. Further, what you will get from this, guys? You can take R square common. Okay. Or here you can write it as R square plus equal to 2R square plus 2R square cos theta. Okay. Solving this, you will get 0.5 equal to 1 plus cos theta, or you will get cos theta equal to minus 0.5, guys. Don't do the mistake. Cos theta equal to minus 0.5. So it is 0.5 at what? 60, but here you are having what? You are having minus 0.5. So it will be what? Theta will be 120 degree. So आंसर क्या हो जाएगा बच्चों? Yes, option D is the right answer, guys. So जिन बच्चों का option D आ रहा है, they are very right, guys. D is the right answer for this question. Let us move to next question. Question number 2. Method of section in truss analysis. You know, guys, truss analysis we carry out majorly by two methods: method of joint and method of section. Method of section is useful to determine the force in a selected member only. Okay. So with method of section, we cannot find out force in all the members. No, we can find out forces in only the selective member. So B is the right answer. Okay, this is the very easy and fastest method. So force in a selective member we can get using method of truss. Yes, guys, paper is there in the chat box. You will find in the chat box paper is there, guys. Okay, in the chat box some tag message you will find. Yes, now you are going to find out something, guys. Please be active in the chat book. Okay, you will get some tag message there. You will be easily able to download this paper. So maximum range of a projectile, guys. So if you are throwing any object, so the horizontal maximum distance traveled by the object is what? This is what? This is range. ये क्या होता है उसका range? The horizontal distance traveled, and the vertical maximum distance traveled is what? This is the height. ये क्या होगी आपकी height? Okay. What is range, guys? Range क्या होता है? Range of a projectile is nothing but V square by G into sine 2 alpha. Where this alpha is the angle of inclination, guys. ये alpha क्या होता है आपका? Angle of inclination. Okay. This alpha is the angle of inclination. So this is range. But what is maximum range, guys? Range maximum क्या होती है? Maximum range, if you will get, if this sine 2 alpha is equal to what? 1. And when you will have this sine 2 alpha equal to 1, sine 2 alpha will be equal to 1 when this 2 alpha equal to 90 degree. It means the angle of inclination is 45 degree. Okay. Now, guys, you can see some of the link. At the top only, in the chat box, at the top, you will find some link. And with that, you can easily download this paper. Okay. So, R maximum, range maximum of a projectile is equal to V square by G. And it will be maximum when this angle of inclination alpha equal to 45 degree, guys. So when you are throwing any object at an angle of inclination 45 degree, you will get the maximum range. Okay. And in that case, what will be the height, guys? Height क्या होती है? Height of a projectile is V square by 2G sine 2 alpha. Okay. This is V square by 2G sine 2 alpha, where V is the velocity. You can write it here. Okay. And this alpha is the angle of inclination. Now, what is this height maximum? Again, you will get height maximum क्या हो जाएगी? So height max also you will get when this 2 alpha equal to what? 1. So this is the height maximum, V square by 2G. So when you are throwing the object at 45 degree, you will get height maximum, range maximum. So answer for this question is what? D, 45 degree. Chaliye, let us move to next question. Question number 4. D'Alembert principles. What is D'Alembert principle, guys? D'Alembert principle. What is that? According to this D'Alembert principle, guys, we know the system of forces which are acting on a body, they are in dynamic equilibrium with the inertia forces. Okay. So a system of forces, let us consider a body, and there are so many forces suppose acting on this body. Okay. So this is body, and these are the forces acting on this body, and suppose this body is in motion due to the action of these forces. So this body is in dynamic equilibrium with what? With its inertia force. So if you will consider here some kind of inertia force Fi, and suppose this force, all these forces, they are having some resultant force Fr. Okay. So this Fr is the resultant force, Fi is the inertia force, and according to D'Alembert principle, what you can say, a body is said to be in dynamic equilibrium with its inertia forces. So actually with that D'Alembert principle, we are converting a kind of kinetic problem into a static problem by introducing a inertia force which is equal in magnitude like the resultant force, but it is opposite in direction. It is very similar to Newton's second law of motion, guys. The algebraic sum of all the forces is equal to mass into acceleration. That is second law of Newton's second law of motion, NSL2. And if you will take what equilibrium of what, that inertia forces, mass into acceleration, and the algebraic sum of all the forces, then net force will be what, 0. So you can consider a body is in dynamic equilibrium with its inertia forces, or you can convert a kinetic problem into a equivalent static problem using this D'Alembert principle. So D is the right answer. Very good, guys. Please keep responding. Next question in front of you. It is a very good question, guys. बहुत अच्छा question है. It's looking like simple, but it's a very good question. Please try to answer. Question number 5th in front of you. If a solid cylinder and hollow cylinder of the same mass, there are two cylinder, guys. One is hollow, another one is solid. Both are having same masses. They are allowed to roll down in a over an inclined plane. So over an inclined plane, they are allowed to roll down. Now, what will happen? Which cylinder will reach to the ground first? Both are going to reach at the same time. Solid will reach first, hollow will reach first. What you will say, guys? Now I'm waiting for your response. Let me tell you the data. So data is something like this. This is the inclined plane. Okay. This is the inclined plane, and here you are having a cylinder. यहाँ पे क्या आपके पास cylinder है? But you are having two cases. You are having two cases. Case 1, case 2. We are having two cases. Case 1, case 2. Case 1 you can consider a kind of solid cylinder. Okay. Case 2 you can consider a hollow cylinder. Hollow cylinder. And obviously when you are comparing, it means both are at the same height, guys. It is not like that ki solid you are rolling from a height h1, so hollow you are rolling from a height h2. It is not like that. Both are at the same height only. So this is the height h. Okay, now you are allowing them to roll down. So he is asking you which one is going to reach to the ground first. Okay, now try to answer, guys. Guys, what is the interesting thing here? Both are having same mass. So mass of hollow equal to mass of solid is same. Both are at the same height. So how much energy they are having? The energy is what? The potential energy, because they are at some height. So they are having potential energy, and that potential energy of hollow, potential energy of solid is same, and that is nothing but mgh. So this is the initial potential energy, guys, which both hollow and solid cylinder are having. Now what is going to happen? When you are going to allow this cylinder to roll down, the potential energy is going to convert into the kinetic energy. But you will have two kinetic energy in translation as well as kinetic energy in the rotation. Okay, so you can write it here. The total energy, potential energy, mgh, that is equal to what? Mgh, that is equal to the translational kinetic energy, that is half ms. Mass is same, so there is no need to write ms, but you can write it as vs, solid. Okay, so half m vs square plus half I omega square, something like that. Okay, half I omega square. Similarly, here also you can write mgh, that is equal to half m v hollow square plus half I hollow omega square. Okay. Yes, guys, getting idea? Now, how much is a moment of inertia of a solid? Solid का moment of inertia क्या होता है बच्चों? This is mr square by 2. This is mr square by 2. And how much is a moment of inertia? Mass moment of inertia of hollow. Okay, that is nothing but mr square. Now if you put it here, these two things, and further if you replace this omega by what? V equal to r omega. So if you replace omega square equal to v square by r square, you will get some idea. Now let us do this just to check which one is having more velocity, more translation velocity, because the cylinder which is having more translation velocity, that is going to reach first, guys. Okay, so here you can put it here, half mass is same, so m vs square plus half mr square by 2 into v square by r square. So this is also the velocity of what? Solid only. So this r square will cancel out. So you will have this, this is 1 by 4, this is 1 by 2. So you will get a 3 by 4 m vs square. 3 by 4 mvs square. Similarly, here also, if you will do the similar kind of analysis, you will get mgh equal to half m vh square plus half mr square into v square by r square. So again, this will cancel out. This is the velocity of what? Hollow. This is the velocity of hollow, guys. ये velocity किसका है? This is the velocity of hollow. So solving this, what you will get, guys? You will get, because this is also 1 by 2, this is also 1 by 2, you will get this is equal to mvh square. This is mgh. So this is also mgh. Okay. Now solving this will cancel out. This will cancel out. Now which velocity is going to come out more, guys? Which translation velocity is coming out more? The solid translation velocity is more or the hollow translation velocity is more? Guys, easily you can check it here. This is what vs square equal to 4 by 3 gh, and here you can check vh square equal to gh. Which one is more? So obviously the translational velocity of solid is more, then the solid is going to reach first, guys. Solid is going to reach to the ground first. Other than that, one more idea you can have, guys. Here if you will check, the sum of the translational kinetic energy plus rotational kinetic energy, the total energy is same. Total energy of hollow and solid both are same, but the rotational kinetic energy of the hollow will be more. Why the hollow will have more rotational energy, guys? Because the hollow is having more moment of inertia. The hollow is having more moment of inertia. That's why the rotational kinetic energy of the hollow will be more, but the total energy is same. That's why the translational kinetic energy of the hollow is less, and the solid is having lesser rotational kinetic energy. That's why it will have more translational kinetic energy. It will have more translational velocity, and it is going to reach to the ground first. So the answer for this question will be what, guys? The answer will be solid will reach to the ground first. B is the right answer. Very good question, guys. I hope it is very much clear to all of you. B is the right answer. Okay, guys, there is some link at the top. Actually, at the top you will find some link. Use this link to download. Okay, that link is there. If you click on that, you will be easily able to download this paper. Please download, because that will help you to actually try each and every question with me. Chaliye, let's move to next question. Question number 6. So this is question number 6, guys. The resultant of two forces P and Q is R. दो forces का resultant क्या है बच्चों? R है. Means you can write it here, R square equal to P square plus Q square plus 2PQ cos theta. The resultant of two forces is R, something like that. Now if you will double the R, if you will double the Q, the new resultant force is perpendicular to P. Guys, I think this formula you need to remember. Okay, one more formula is there. What is that? That is the angle between the resultant and the force P, or horizontal. What angle resultant is making with the horizontal? What is that? That is tangent theta. Tangent theta. Okay, and tangent theta is nothing but Q sin theta divided by P plus Q cos theta. Yes or no? So this is the angle the resultant is making with the horizontal. Tangent theta equal to Q sin theta by P plus Q cos theta. Okay, that easily you can get. Chaliye, I'm not going to this detail from where we are getting this, that you need to remember. The angle resultant is making with the horizontal. Now if you will put it here, because you are doubling the Q, the tangent theta is becoming what? The theta is becoming 90 degree. The resultant is making an angle with 90 degree with the P, perpendicular to P. So this is force P, this is Q, something like this. This is 2Q, and this is resultant, guys, something like this. This is the resultant, and resultant is perpendicular to P, something like this. Now if this is 90, then tangent 90, it will be infinity. Okay, so it will be something by 0. Okay, something by 0 means 2Q sin theta divided by P plus Q cos theta, 2 cos theta actually, 2 cos theta. So from that, what you can say, sir, this P plus 2Q cos theta, this is equal to 0, or you can put it here, P equal to minus 2Q cos theta. Okay, P equal to minus 2Q cos theta. So this data we are actually getting from this analysis. The angle the resultant is making with the horizontal. Now if you will put it here, only you need to replace this P here. So R square equal to minus 2Q cos theta square. This is P plus Q square plus 2 into minus 2Q cos theta into Q cos theta. Solving this, actually, you will get R square equal to Q square. You can check, and the R becomes equal to Q. Resultant equal to what? Q, guys. For this case, resultant equal to Q. So answer क्या हो जाएगा बच्चों for this question? C will be the right answer. R equal to Q. Please check. Okay. This is the answer, guys, for this question. Now let us move to the next question, question number 7. Again, very good question, but slight changes you need to make in this question. I don't know you tried this question or not earlier, but this question is very good actually. There are two objects moving with uniform speed and they are 5 meters apart after 1 second. There are two objects, they are moving with uniform speed. They are 5 meters apart after 1 second. When they are moving towards each other, actually that word is confusing, moving towards each other. So they are not moving towards each other means this is one, this is another. Towards each other means they are moving opposite to each other. They are not moving in the same direction. They are moving opposite to each other because they are not separated actually. They are at the same distance only, something like this. So this is member 1, mass 1. This is mass 2. So here I'm correcting one data because with that you will not be able to calculate without that. So they are moving not towards. Actually, it is better to write it here. They are moving opposite to each other. Towards का मतलब ही वही है. Towards. Two masses moving towards each other means they are moving opposite to each other. But actually, why I am writing here word opposite? Because opposite is most suiting because they are at the same distance initially. Initially they are lying at the same position, and now they are moving opposite to each other. That's why I'm correcting it. Opposite. Okay. Now what he is saying? Suppose this is having velocity v1, this is having velocity v2, and they are moving opposite to each other. So after 1 second, they are separated by a distance 5 meters. So guys, what is the relative velocity in this case? So this is case 1. This is case 1. What will be the relative velocity here? Because the masses are moving in opposite direction, so the relative velocity will be v1 plus v2. So v1 plus v2 relative velocity, and that is equal to what, guys? Distance per unit time. How much is the distance? 5 meters. How much is the time? 1. So we are getting first equation, v1 plus v2 equal to 5. This is the first equation, guys. Now, what is the case 2, guys? In case 2, they are moving in the same direction. This is 1. This is 2. They are moving in the same direction, v1, v2. Now what will happen? In this case, what will the relative velocity? Relative velocity will be v1 minus v2. And when they are moving in same direction, they are traveling a distance of 1 meter in 1 second. So v1 minus v2 is 1 by 1. It means v1 minus v2 equal to 1. This is second equation, guys. Okay, this is second equation. Now if you will put it here, v1 minus v2, this is equal to 1. So you can add it here. 2v1 equal to 6. So v1 equal to 3 meter per second. v1 कितना हो जाएगा बच्चों? It will be 3 meter per second. And if v1 is 3, then v2 will be what, guys? v2 will be what? Because this will take this side. So v2 will be what? 2 meter per second. So v2 equal to 2 meter per second. So either by using equation 1 or 2, v1 is 3 meter per second and v2 is 2 meter per second. So 3 meter per second, 2 meter per second will be the answer for this question. Means option B is the right answer. I hope this is very much clear to all of you guys. Option B, 3 meter per second and 2 meter per second is the answer, guys, for this question. Very good mechanics question actually they asked in this particular paper, guys. Okay, chaliye, let us move to next question. Question number 8. Okay, this is question number 8, guys, in front of you. There is a ball which is dropped vertically downward from the top of a building and another one is thrown horizontally. So there are two cases, two scenarios. You are throwing the ball vertically, something like this. This is case 1. In second case, you are throwing it horizontally, something like this with some velocity Vx. Okay, so this is what, this is case 2. Case 1, you are just releasing it vertically down. Case 2, you are throwing it horizontally. In which case, the ball will reach to the ground first. दो क्वेश्चन मैं आपसे इसमें पूछ रहा हूं बच्चों. The question first is what? Which ball is going to reach to the ground first? And in second, in which case? Case 1, case 2, or in both the cases, the ball is going to reach at the same time? That is the question. And in second case, I'm asking you guys, which one is going to strike the ground at more velocity? There are two cases. One, you are releasing the ball vertically, and another case, you are releasing the ball horizontally. In both the cases, it is going to reach to the ground. In first case, it will reach to the ground like this. Okay, and in second case it is going to reach like this. Okay, and in both the cases the vertical distance travel is same, guys, but in case 2 it is going to travel some horizontal distance also, and it is going to travel some vertical distance also, like suppose say height h. Okay, now please try this question. So guys, here, you know, using this relationship S equal to ut plus half at square, because this both are a kind of case of what, a kind of free fall. So S is what? S is the vertical distance travel. Let me take the velocity as what? The velocity in the y direction. So when you are releasing it horizontally, there is no initial velocity in y direction. Whatever velocity you are providing initially, that is the velocity in x direction. So S I am writing it as h, u I am writing it as uy, t is the time plus half, a will be g, acceleration due to gravity, and t is the time, t square. Yes or no, guys? So in initially when you are throwing the ball horizontally, there is no velocity in y direction. You are giving the velocity in what? X direction only. Okay. So what you will get from this, guys? Time t will be what? T is equal to under root 2h by g. So this is the time you are going to get in this second case. So this is case 2. Similarly, in first case, case 1, you are you are releasing the ball vertically downward. So this is also case of free fall. So S is equal to what? Ut plus half at square. Here also, what is the initial velocity, guys? Initial velocity is 0. Okay, there is no initial velocity. You are releasing it like that. So here the velocity is Vx, but Vy is 0. Here, what is the initial velocity? When you are releasing it downward, something like this, velocity is 0. So how much is the vertical distance traveled? That is h equal to half gt square. So again, you will get the same time. So whether you are releasing it by what? Like this or like this. In both the cases, they are going to take the same time. But what is the difference, guys? In the first case, when it is going to strike the ground, it will have only the velocity in y direction. It will have only Vy. But Vx will be what? 0. Okay, but in this case, the ball will have two velocities. Here, if you will calculate Vx, so here Vy is the velocity, Vx is 0. Here also it will have some Vy velocity, which will be same, because both are reaching to the ground at same time. So their velocity in the y direction, that will be same. Both are reaching to the ground at same time. You can calculate velocity also, guys. Time you are having, you can calculate the velocity, because both are traveling the same vertical distance. So their velocity in the y direction, Vy, is same. So whether you are releasing it like that, whether you are releasing it like that. But what is the difference? In this case, there is no velocity in x direction. So the total velocity is Vy only. But here, it is having some velocity in x direction also, Vx. Okay. So you will have two velocities, Vx also, Vy also. And Vx also you can find out, taking the case, initial case of what? Some kind of horizontal distance x. So you are throwing it with some initial velocity Vx in the x direction, and then the distance travel will be what? It will be x, the horizontal distance traveled. Okay, then easily you can find out Vx. So what I want to say, guys, here in second case, the resultant velocity will be what? The total velocity in the second case, Vt will be what? Under root of Vx square plus Vy square. So both are going to exist. This Vx is not 0 in second case. That's why the second case, the ball is going to strike to the ground at more velocity. Are you getting, guys? So the velocity with which the case 2 means, when you are throwing the ball horizontally, the velocity of the impact will be more, but both are going to reach to the ground at same time. I hope this is very much clear, guys. Please read it again and go through the analysis part. If it is clear with all of you, if it is clear to all of you, please thumbs up. Okay. Yes, they are going to strike at the same time. Bilkul sahi. They are going to strike at the ground same time, but their velocity of impact, because the question can be framed like that. In which case velocity of impact will be more? So velocity of impact will be more in which case, guys? In the case when you are throwing the ball horizontally, generally, because some student, they can have perception that when we are releasing it vertically, you will have more velocity of impact. No, the second case you will have more velocity of impact, because you will have Vy also, Vx also. The total velocity will be more. Chaliye, let us move to the next question, question number 9. Question number 9, guys, in front of you. Please read and try to answer. The linear acceleration A of a body of radius r with angular velocity, angular acceleration alpha. What is linear acceleration? So he's asking you some relationship between the linear acceleration and angular acceleration. Okay, you know, guys, what is the relationship between V and omega? V equal to R omega. This is the relationship, V equal to R omega. Okay, so if you will differentiate both the sides with time, what you will have? You will have dV by dt, that is equal to R dW by dt. So this is what, this is the linear acceleration A, R. What is this? This is the angular acceleration alpha. So linear acceleration is equal to R alpha. That is the relationship between the linear acceleration and angular acceleration. So the answer for this question will be what? B. A equal to alpha R. This is the answer, guys. Note A, guys. Vipin, A is not right. B is the answer. A equal to alpha R. This is the answer. Please check. B is the answer. Next question, question number 10 in front of you. Okay. There are two forces acting at a point. The first force has x and y component, 3n and minus 5n. The second resultant force is minus 4n. So एक force क्या दिया बच्चों आपको? First force क्या है? F1, what you can say? This F1 is nothing but it's having two component in x and y, 3 and minus 5. So you can write it as 3i cap minus 5j cap. Okay. Similarly, what is the resultant force? Resultant force is minus 4i cap. Something like this. Okay. Now he's asking you the second force. What is second force? So second you can write it as xi plus yj. Okay. Now the resultant of F1 and F2 is Fr. So you can write it here F1 plus F2, that is equal to Fr. So from that you can write it here 3i minus 5j plus xi plus yj plus yj, that is equal to minus 4i. Okay. So now further if you will solve, what you will get? 3x. So x plus 3, that is equal to minus 4. This is the first equation you are going to get. And what is the second equation, guys? Y minus 5, that is equal to 0. Okay. X plus 3, that is equal to minus 4. And second is y minus 5, that is equal to 0. So this is the second equation. So solving this, what you will get? You will get y equal to 5 and x equal to 7. So x equal to 7, y equal to 5. Please check. No, x equal to minus 7, guys, because this is 3. This will go this side. So this will be minus 7, guys. So x is minus 7 and y equal to 5. So the resultant force will be something like this. Resultant force, or what you can say, the second force F2 will be minus 7i plus 5j, or the component of the F2 in x and y direction will be minus 7 and 5. So A is the right answer, guys. Option A क्या हो जाएगा? This is the answer for this question. Very good, Vipin. Please, other also, guys, please keep trying. Try to answer. Next question is a direct one. Next question is direct question, guys, in front of you. A cantilever beam of length L is subjected to a moment m at the free end. Okay, so there is a cantilever beam subjected to a moment m at the free end. The moment of inertia of the beam about the neutral axis is I, and E is the Young's modulus, the magnitude of maximum deflection. Guys, maximum deflection you are going to get here only, and that maximum deflection will be what? That deflection will be ml cubed by ml square by 2ei. Okay, so this is the maximum deflection you are going to get in this case. Okay, this is the maximum deflection, guys, we are going to get in this case. So this question is a direct one. Okay, please check. So answer for this question will be what, guys? Option A is the right answer. Let us move to next question, question number 12. Slightly interesting question, guys. Please try to answer. The question is something like this. Let me read it for you. The elongation of a conical bar. So there is a conical bar, something like this. There is a conical bar, guys, something like this. So the elongation of this conical bar under its due to its own weight, deflection due to its own weight. So this is a conical bar. And second case, you're having a prismatic bar, something like this. What is asking you? They're asking you the elongation ratio. The elongation of conical bar. Suppose for the conical bar, the deflection is delta 1, and for this, the deflection is delta 2. If you know the formula, then easily you will get the answer. What is asking, guys? The elongation of the conical bar due to its own weight in comparison to a prismatic bar of the same length. Both are having same length. But this one is a conical bar and this one is a prismatic bar. A bar with a uniform cross-sectional area. Please try to answer. C. Guys, C is not actually right for this question. C is not right. C is, please check. It may be right also. Please check. Vikas is saying C. Vikas Kumar is saying C. Others also, guys, please try to respond. Guys, for this case, conical bar, if you write the deflection, this is nothing but W L square by 6E. And for the case of prismatic bar, the deflection equal to W L square by 2E, where W is the load, same load, L is the length, both are having same length. Okay, E is the Young's modulus of elasticity. Okay, now this is delta 1, this is delta 2. So now if you will check it here, the elongation of conical bar, this is what, guys, delta 2, delta 1 is nothing but it is 1/3 of the delta 2, guys, because if you will divide this delta 2 by 3, you will get the deflection of the conical bar. Then yes, the option C kya ho jayega, guys? This is the right answer. 1/3 is the right answer for this question, because due to the self weight, the deflection of the conical bar will be WL square by 6E, and for the prismatic bar it will be WL square by 2E. Chaliye, let us move to next question, question number 13. A beam is said to be of uniform strength. What is beam of uniform strength, guys? Which is having bending moment in same throughout the beam. Bending moment is same? No. Deflection is same throughout the beam? No. The bending stresses are same throughout the beam. So beam is said to be of uniform strength if it is subjected to similar kind of bending stresses at all the cross sections. At all the cross sections, if the bending stresses are same, then only you can say yes, this is a beam of uniform strength. So option C kya ho jayega, bachon? This is the right answer for this question. Now next question, question number 14 in front of you. Question number 14 in front of you. Please try. For a simply supported beam of length L, there is a simply supported beam of length L, the bending moment M is described by. So M is equal to, bending moment M equal to A into X minus X cube by L square. Okay, where X is greater than equal to 0, less than equal to L. Now, what will be the shear stress? What will be the value of A? He's asking the value of A when shear force is 0. The value of A when shear force is 0. Guys, what is shear force? Shear force is nothing but the slope of the bending moment. So if you will take it here, dm by dx, this is nothing but the shear force. So here you can differentiate it. So A into 1 minus 3x square by L square. And he's saying the shear force is 0, then find out the value of A. So just equate it equal to 0. What you will have? Equating it equal to 0, what you will have, guys? What relationship you will have? So 1 minus 3x square by L square, that is equal to 0. Or from that you can write it here, 3x square by L square, this is equal to 1, or x equal to L by under root 3. X equal to under root 3, yes. This will be here, L, it become L, and this is L by under root 3, something like this. So x equal to L by under root 3, guys. This is the answer for this question. So let's check the option L by under root 3. Okay, so L by under root 3. So this must be L by under root 3, because this is not like this. So x equal to L by under root 3. This is the answer, guys. Please check. So we can go with B, but some correction is required. X equal to L by under root 3, guys, because under root L will not be right. That is actually going to change the units also. X is the distance, L is also the distance. So under root meter, that is meter ki power 1 by 2. How it will be equal to meter? That is not right. So definitely we will have X equal to L by under root 3. Okay, now unit will be balanced also. So X equal to L by 3, this is the right answer. That small correction you need to make in this particular question. Let us move to next question, guys. Question number 15. Question number 15 in front of you. What is poisonous ratio for cast iron? This is actually a factual question. Direct factual question. You know, guys, what is poisonous ratio? It is a ratio of the lateral strain to the longitudinal strain. Okay. Poisonous ratio is the ratio of the lateral strain to the longitudinal strain. And for most of the engineering materials, okay, for most of the engineering materials, this mu varies between 0 and 1, 0 and 0.5, sorry. The maximum value of mu for a engineering material is 0.5 and mu equal to 0.5 for what, guys? For rubber. For rubber, mu is equal to 0.5 and for cork, this is equal to 0. Because in cork, there will be no lateral strain. Okay. So for cork, mu is 0, for rubber it is 0.5 and for most other engineering materials, it varies between 0 to 5. It may be negative also for some kind of biomaterials. For biomaterial, it may be negative. Okay. But its value for cast iron actually varies between 0.23 to 0.27. Okay. For cast iron, it varies between 0.23 to 0.27. Fine, guys. So A is the answer for this question. Please check. Next question, guys, in front of you. There are two tapering bars of same material subjected to tensile load P. So there are two tapering bars. There are two tapering bars, something like that. So let me consider it like that. So there are two tapering bars, something like this, of same material subjected to a tensile load P. The length of both the bars are same. दोनों का length क्या है? Same है बच्चों. This bar, both are having same length. Okay. The diameter of the larger part of the bar is D. Larger part का diameter क्या है? D. Okay. Suppose this is bar A. The smaller diameter, the diameter of bar A is smaller and is D by 2. So suppose this is bar A. So at the smaller end, the diameter is D by 2. Okay. Now let us take the second bar also. The second bar is something like this. This is also of the same length, same material. Same length, same material. Only what is the difference? The longer end is having diameter D, but the smaller end is having diameter D by 3. And this is also subjected to the same load P. So there are two taper bar. There are two tapering bar. First is having longer diameter D, smaller diameter D by 2. Second one is having longer diameter D, smaller diameter D by 3. Then he is asking you the ratio of the elongation of bar A and bar B. Guys, what is the elongation? Elongation for a tapered bar. What is the elongation, guys? This is nothing but load P, L by pi. 4 will be there. D1, D2. Okay, this is D1, D2 into what? Young's modulus. So this is the deflection of a tapered bar. 4PL pi D1, D2 into E. Now if you write it here, delta 1 or delta A, deflection of bar A. So this is 4PL by pi D, because the larger diameter is D and the smaller diameter is D by 2E. Something like this. What is delta B, guys? Delta B is 4PL. Both are subjected to the same length. They are having same length. Pi D into D by 3 into E. Yes or no? So all things are same. Only here you will have this 2, you can write it here. Other than here, this 2 you can write it here. Okay. And here this 3 you can write it here. So now the ratio of deflection A by deflection B, that will be 2:3. That is only, you cannot write it as 3:2, guys. That will be wrong. So please check. He's asking you the ratio of the elongation of A and B. Elongation of A and B. So that will be 2/3. So ratio will be 2/3. Okay. So B is the answer for this question. Please check. Yes, Vipin, very good. B is the right answer for this question. Very good, guys. Now let us move to next question, question number 17. Plane stress at a point in a body is defined by principal stresses, 3 sigma and sigma, the ratio of normal stress to the maximum shear stress on the plane of maximum shear stress. So this is a case something like this, guys. The plane stresses at a particular cross section are defined by principal stresses 3 sigma, something like this. So here, suppose this is 3 sigma, this is 2 sigma. If you will draw the Mohr circle, okay, and this is the plane of maximum shear stress. This is the plane of maximum shear stress, and how much is the maximum shear stress, guys? That is sigma. Okay, this is the maximum shear stress, sigma. And at this particular plane, guys, at this particular plane of maximum shear stress, how much is the normal stress, guys? Here, how much is the normal stress? The normal stress is 2 sigma plus sigma. This is yes, no, this is not 2 sigma. This is sigma only, guys. Okay, this is sigma only. Let me check. Let me write it here. So this is sigma, 3 sigma and sigma. So this is sigma. So this is sigma, and this is what, guys? What this is sigma. So sigma plus sigma, it will be 2 sigma. So at this particular plane, the ratio of the normal stress to the shear stress is nothing but 2 sigma by sigma. So it will be 2 only. So answer will be what, guys? The answer will be option B. Option B will be the right answer. Very good, Vipin. Tarun, your answer is also right. Very good. Now we can move to the next question, question number 18. After engineering mechanics, now we are having some questions from strength of material. Guys, thermodynamics, heat transfer, IC engine, these questions you are going to find out much more direct. Okay. Initially, like first 20-30 questions, they are from mechanics and strength of material. That's why we need to solve actually these questions. Okay. But easily, quickly, we will be able to move to the 100. Don't worry. Actually, total number of questions we need to solve 150. So there is a outside diameter of hollow shaft is twice that of the inside diameter. आपको outside diameter दिया बच्चों. DO, outside diameter of the hollow shaft is twice of the inside diameter of a hollow shaft. The torque carrying capacity of the shaft is MT1. So this is hollow one. Hollow के लिए लिख देते हैं बच्चों. Suppose this is hollow one. Hollow के लिए torque carrying capacity is what? MT1. This is the torque carrying capacity of the hollow. Solid shaft of the same material has the diameter equal to the outside diameter of the hollow shaft. So this is having outside diameter DO. Okay. This is having outside diameter DO. Now, it is having torque carrying capacity MT2. It is having torque carrying capacity MT2. What is asking you? Is asking the ratio of MT1, the torque carrying capacity of shaft 1, hollow 1, to the torque carrying capacity of the solid 1. What is the torque carrying capacity of the hollow to the solid 1? Now, guys, question is very easy, simple. You know, guys, the torsional equation, if I write it here, T by J equal to G theta by L, this is equal to tau by R. Okay. So now what is this shear stress tau? That is equal to TR by J. TR by J. So here you can write for two different cases. So let me write it here. For the shear stress in this particular member, this is having torque carrying capacity MT1. This having radius, what? This DO by 2. So polar moment of inertia will be what, guys? This is pi by 32 into what? This is DO ki power 4 minus DI ki power 4. DO ki power 4 minus DO ki power 4. Because this is hollow 1, guys. This is hollow 1. Okay. This is solid 1. And here also you can write for solid 1. This is MT2 into DO by 2 into what? This J. This is pi by 32 into DO ki power 4. As this is also given to you, guys. DO is 2 times of DI. Okay. DO is 2 times of DI. So easily from that, you will be able to solve this. Okay. So now please put this and try to find out this ratio. Okay. Please try to find out this ratio because he is asking the ratio of MT1 by MT2. Guys, both are of the same material. दोनों क्या हैं? They are of the same material. So their properties are same. He is asking the torque carrying capacity. So their maximum stress is induced in a particular component that will be same. So whether you are having hollow or you are having solid, both the stresses will be same. Now if you will equate it here, this and this, अगर आप इसको equate कर दें, so let me write it here, mt1 into, this is do, this will be pi into do की power 4. Let me write this as 2di, इसको मैं 2di लिख देता हूं. So this will be 2 की power 4. So 2 की power 4 करोगे तो it will be something like this. Let me write it here, 8 and this will be 16 di की power 4 minus di की power 4, something like this. Okay, outer diameter is 2 times of the inner diameter. Now here what you can write it here, this is 2 also you need to write, this is 32, let me write it here 32, and here you are having do by 2. This is equal to mt2 into do divided by 2 divided by pi by 32 into do की power 4. Okay, now try to find out guys, because di also you can replace this by do by 2. Okay, तो इसको replace कर दो पूरे को, this you can replace it by what, 15 di की power 4. Okay, 15 di की power 4, or di is nothing but do by 4. Okay, do is nothing but do by 4. So guys, solving this you will get the ratio. If you will check it here, this ratio mt1 by mt2, you are going to get 15 by 16. Just check it out. By solving this you will get the ratio of mt1 by mt2, the torque carrying capacity of the hollow one, the torque carrying capacity of the solid one. This will come out 15 by 16. So option A क्या हो जाएगा बच्चों? This is the right answer for this question. Please check your answer. You are getting this or not? So I equated this only because both are of the same material, so their strength, shear strength will be same, maximum. So we are actually interested in getting the maximum torque carrying capacity. Both are of the same material, that's why I equated with this shear stress induced in the hollow one, and this is the shear stress induced in the solid one. And using the torsional equation, I have written this particular shear stress. If you will get this A 15 by 16 is the right answer for the ratio of the maximum torque capacity of the hollow to the maximum torque capacity of the solid one. Let us move to the next question, question number 19. Another interesting question guys, another interesting question from strength of material. If the width of a simply supported beam carrying an isolated load at the center is doubled, he's saying the width is doubled, then what will be the deflection at the center? How the deflection is going to change? How the deflection is going to change? Guys, if you will take it here, a kind of simply supported beam. So this is subjected to a kind of point load at the center. So deflection will be what guys? How much deflection you are going to get at the center? The deflection at the center you will get this WL by 48 EI. This is the deflection guys you are going to get for a simply supported beam subjected to a point load at the center. Now from this you are not changing the load, you are not changing the length, okay, you are not changing the material. What you are changing guys? You are changing the moment of inertia, because you are changing the width of the beam. You are changing the width of the beam. So can I write it here guys? The deflection inside the beam is inversely proportional to moment of inertia. And what is this moment of inertia guys? For a kind of rectangular cross-sectional beam, something like this, suppose something like this. This is B, this is D. So this is nothing but BD cube by 12. Okay, this is nothing but BD cube by 12. Now, can I write it here? The deflection is inversely proportional to what? It is inversely proportional to B. Yes or no? Because the area moment of inertia is BD cube by 12, where B is the width. So deflection is inversely proportional to the width. Now, how the deflection is going to change? Can I write it here? Delta 1 to the delta 2 is equal to B2 by B1. Yes or no? Because delta I can write it as delta equal to C by B. Keeping all other things constant, like the material, the length, the load, delta equal to C by B. So you can write it here, delta 1 by delta 2 is nothing but B2 by B1. So you are doubling the width. आपने width को क्या कर दिया? Double कर दिया. So B2 is 2 times of B1. So 2 times of B1. So this deflection delta 2 will be what guys? He's asking you what the deflection of the beam at the center is changed by. Double mat kar dena, because he's not asking you the initial deflection. Delta 2 becomes half of the delta 1, guys. Delta 2 becomes half of the delta 1. That's why the answer will be option A. Please check. If it is clear to you, please check. A is the right answer, guys, for this question number 19. 1 by 2. The deflection becomes half. अगर आपने width को double कर दिया, the deflection at the center becomes half. It will be delta by 2. Okay. Yes. A is the right answer for this question. Note D. चलिए. Let us move to next question. Question number 20. When two mutually perpendicular principal stresses are unequal but like. Very simple direct question, guys. Though mutually perpendicular principal stresses, you will get a more circle on the right of this, something like this, because the principal stresses are what? They are unequal. They are unequal but like. They are unequal and like. Something like this. Suppose sigma x, sigma y. Okay. So in that case, the maximum shear stress will be what, guys? The maximum shear stress is nothing but the radius of the Mohr circle. The radius of the Mohr circle is going to give you the maximum shear stress. Okay, or what you can say, tau max is nothing but sigma 1 minus sigma 2 divided by 2. So let me write it here, sigma 1 sigma 2. Okay, or something like that only. So tau max equal to sigma 1 minus sigma 2 by 2. So radius of the Mohr circle, or half the diameter of Mohr circle, is going to give us the tau max. B is the right answer. Very much direct question. If you studied about this Mohr circle, easily in seconds you will be able to answer this question. In the case of two mutually perpendicular principal stresses, if they are unlike and they are unequal but like, means they are both of kind of tensile in nature, but they are unequal, then in that case the tau max will be the radius of the Mohr circle, or half the diameter of the Mohr circle. Let us move to next question, guys. This is a kind of factual question. Direct you need to remember, because otherwise it will take much time to derive this. The deriving and driven shaft connected by hook joint. You know, guys, for what purpose we use hook joint? Hook joint we use to join two non-parallel shafts. Okay, and in that case, this is the case actually, for equal speed, the tangent theta will be plus minus under root cos alpha. B is the right answer, guys. For this case, directly you need to remember this. Okay, otherwise it will take much time to derive this. Hook joint we use to join two shafts which are interacting, means they are intersecting also. The shafts are intersecting, but they are non-parallel. Non-parallel intersecting shafts are joined by hook joint. Next question, guys. A shaft between two bearing is rotating with a disturbing mass. So how much is the disturbing mass, guys? Disturbing mass is 25 kg. And how much is the radius? At what radius this disturbing mass? This is at 2 centimeter. Now, how much is the balanced mass? Balanced mass we want to find out. At what distance you want to mount this balanced mass? You want to mount it as a 5 centimeter. Okay, so how to find out? In case of balancing of rotatory masses, you can write it as m1 r1 w1 square equal to m2 r2 w2 square. But here in case of rotation, this w1 w2 will be same. So you can write it here md rd, that is equal to mb rb. So the balanced mass will be the disturbing mass. How much is the disturbing mass? That is 25 into how much is the balancing radius? Yes, sorry, this is not B, this is D. Okay, this is the radius of the disturbing mass. So this is nothing but what? 2 divided by 5. So this will be 10 kg. So amount of the balancing mass required is what? 10 kg. C kya ho jayega is the right answer. Option C is the right answer. Very good. MRV. MRV answer is very right. Now we can move to question number 23. So this is question number 23, guys, in front of you. In an epicyclic gear train, this is not tram, this is train. Epicyclic gear train, something like this. Suppose this is the sun gear. Okay, this is the planet gear, and this one is the annulus, something like this. So the arrangement is something like this. Okay, this is sun, planet, and annulus. Now what he has given you guys? The teeth on the sun gear. Sun पे कितने teeth हैं? 80. How much the teeth on the planet? These are not given. How much the teeth on the annulus? These are 200. तो क्या फॉर्मूला होता है बच्चों? You know the half, or what you can say, the diameter of the sun by 2 plus diameter of the planet, that is equal to diameter of the annulus by 2, something like this. Or what you can say here, what you can write it here, the teeth, number of teeth on the sun gear, half of that plus the number of teeth on the planet, that is equal to the number of teeth on the annulus divided by 2. So sun पे कितने हैं? Sun पे है 80. So solving this you will get 40 plus number of teeth on the planet gear, that is equal to 200 by 2, it is 100. So number of teeth on the planet gear will be 60 answer. So answer for this question will be option A. 60 are the number of teeth on the planet gear. Okay, 60 are the number of teeth on the planet gear. Please check. Let's move to the next question, question number 24. According to Kennedy theorem, if three bodies are moving relative to each other, their relative instantaneous center must lie on straight line. If you studied theory of machine, then easily you can answer. According to Kennedy theorem, the bodies, three bodies, if they are moving relative to each other, their instantaneous center must lie in a straight line. Direct question, A is the right answer. When crank is at the inner dead center, in a horizontal reciprocating engine, then velocity of the piston will be. So this is something like this. So this is the piston, connecting rod, this is crank. This is rotating like this. Okay. So this is like this. So he's saying when the crank is at the inner dead center. So when the crank is at the inner dead center, the position will be something like this. The piston will reach to the TDC. Piston कहाँ reach कर जाएगा बच्चों? This is the TDC position. Okay. Piston will reach to the TDC position. So this is connecting rod and this is crank, something like this. This is crank. Okay. This is crank. So when the piston will reach to the TDC, in case of when the crank is at IDC, this is what guys, this is IDC, inner dead center. Okay. या इसको मैं क्या बोल सकता हूँ, टॉप डेड सेंटर. When the crank is at the extreme outward position, crank की जो extreme outward position है, या piston क्या है, piston is at the here, that is TDC. Okay, and that is what in case of horizontal cylinder we define it as IDC and ODC. Okay, whereas in case of vertical engine we define it as TDC and BDC. The top dead center extreme position of the piston inside the cylinder, that is TDC. Extreme bottom position of the piston, that is known as BDC. But in case of horizontal cylinder, you can define it as IDC and ODC. Crank is at the inner dead center. Okay, so this is inner dead center and this is what outer dead center. ये क्या आपका outer dead center. So crank is at inner dead center. So in this case, the velocity of the piston will be what guys? It will be 0. Velocity क्या होगी यहाँ पे? It will be 0. Option A क्या हो जाएगा? This is the answer for this question. Okay, there is one formula also, if you'll recall, the velocity of the piston is equal to r omega into sine theta plus sine 2 theta by n. Okay, where n is nothing but the length of the connecting rod divided by the length of the crank, or generally you can write it as L by R. This is known as obligatory ratio. So velocity at theta, because if you put it here theta 0, then velocity will be 0. Theta 0, velocity will be 0. So when the crank is at inner dead center, the theta will be 0, because when it is going to deflect, then it is going to take some angle theta. Okay, so at the IDC, when the crank is at IDC, the theta will be 0, then velocity will also be 0. Chaliye, let us move to next question, question number 26. The ratio of the height of porter governor when the length of the arm and links are equal to the height of what governor? You know, guys, Porter governor is a kind of modification in what governor. What we do, we attach some, weight, additional weight we attach at the sleeve. So Porter is a modification in what? What is the height expression in case of what governor, guys? The expression of height in case of what governor is what? That is 895 by h. N square equal to n square equal to 895 divided by h. This is in case of Watt's governor. Watt's governor. And what is the expression in case of Porter governor, guys? This is m plus m by m into 895 by h. So if you take the ratio height, यहाँ पे height ले लीजिए in case of Watt governor, यहाँ पे height ले लीजिए in case of Porter governor. So this is the case of Watt, this is the case of Porter governor. So if you will take the ratio, what will come, guys? The ratio of the height will be what? This will be m plus m by m. So this C is the right answer, guys. C is the right answer. Where this capital M is the additional load provided. This is the additional load provided, and M is the mass of the bowl. So what I have written? Please check. Yes. Thank you, Kaplesh. Yes, this is very right. Here will be 2n actually. I missed this. So V equal to R omega into sine theta plus sine 2 theta by 2n. Yes, very right. So this 2 is there, guys. Chaliye, thank you. Let us move to the next question, question number 27. This is a kind of direct factual question. Minimum number of teeth of standard portion with involute profile and 20-degree pressure angle spur gear. These are 18 actually. The minimum number of teeth of standard portion with involute profile 20-degree pressure angle is 18. Okay. Now let us move to the next question, question number 28. The engine of an aeroplane rotates in clockwise direction. Okay, something like this. Let me take it here, a kind of diagram, something like this. Let me take whatever I can draw here at this moment. So something like this. So engine rotates in clockwise direction. Let us take. So engine is rotating in what? Clockwise direction. When seen from the tail, so you are watching from the tail. Aeroplane takes the left turn. So it is going to take the left turn. The effect of the gyroscopic couple on the aeroplane will be. What do you think, guys? What will be the answer for this question? The effect of gyroscopic couple for this case will be actually to dip the nose and raise the tail. In this case, if you will take the left turn, the nose is going to dip and the tail is going to raise. So B क्या हो जाएगा? इसका आंसर हो जाएगा बच्चों. Option B will be the answer for this question. Let us move to the next question, question number 29. The Corolla's component of acceleration. When this will came into picture, when there is any point which is on a member which is sliding and rotating. Okay. So Corolla's component of acceleration is what, guys? So suppose there is a slider, something like this. This is a slider. This is moving with some velocity v, and it is rotating with some angular velocity omega. So the Corolla's component of acceleration will be 2v omega. Okay, and this will be what, guys? This is going to lead the velocity, sliding velocity by 90 degree. So what is the answer, guys, for this question? The answer will be B. It is going to lead the sliding velocity by 90 degree. Corolla's component of acceleration is at a 90 degree from the slider velocity. So this V is the velocity of the slider. This is the angular velocity, and this is the Corolla's component of acceleration. So this is going to lead the velocity by 90 degree. Okay. Next question in front of you, question number 30. The number of instantaneous center in a six link mechanism. How many number of instantaneous center, guys? How many number of instantaneous center? That is nothing but n into n minus 1 divided by 2. So how many n? N are the number of links. So 6 into 5 divided by 2. So it will be 15 is the right answer. Number of instantaneous center equal to n into n minus 1 by 2. So number of links are 6. So number of instantaneous center will be 15. Next question, question number 31. The space centroid of a disk on a straight line. So if you are rolling a disk, on a straight line, something like this is a disk. So when it is going to come out in contact with this plane, straight line, so the space centroid will be what? This will be a kind of straight line. The space centroid you will have on the straight line. So A क्या हो जाएगा, C क्या हो जाएगा बच्चों? This is the right answer for this question. C is the right answer for this question. Let us move to next question, question number 32. Cam flower extensively used in aircraft engine. We use cam flowers in aircrafts. Why? What is the reason? Used in aircraft because roller flower they are having very less friction. Roller flower we use in the aircraft, knife edge flower, flat edge flower, spherical flower. No, we use roller flower in case of aircraft engine. So D is the answer for this question, guys. Please check. Let us move to the next question. The minimum number of it, I think similar kind of question that earlier also we answered. Elon Musk is there, great. Elon Musk is there in our session, good. The minimum number of teeth in a rack and pinion for a 20-degree pressure angle. Again, it is 18. The answer is what? 18. A shaft carrying 3 rotors will have. Guys, usually the number of nodes कितने होते हैं? Number of nodes are actually in general maximum number of nodes actually. What you can say? Maximum number of nodes in general are what? These are one less than the rotor. Number of rotors -1. So how many rotors are there? 3 rotors. So how many number of nodes maximum you will get? 2 number of nodes you are going to get. A shaft carrying 3 rotors will have 2 nodes. Number of nodes will be in general one less than the number of rotors. So number of rotors are 3. So number of nodes will be 2. In this case, let us move to next question, question number 35. In vibration isolation, if this ratio omega by omega n, omega is the velocity of the angular velocity of the disturbing force, angular frequency, sorry, that is a disturbing force, and that is your natural frequency omega n. If omega by omega n is greater than 1, then the phase difference between the transmitted force and disturbing force. Actually, guys, if you will go through the transmissivity expression or isolation factor or force transmissibility, if you will go through that will become negative, guys. Ye kya ho jayegi? It will become negative because if this ratio is greater than 1, this will be negative. So in that case, the phase difference between the transmitted force and the disturbing force, there will be out of phase, and the angle between these will be what? 180 degree. So isolation factor, force transmissibility will be negative if omega by omega n is greater than 1. So C is the right answer. The transmitted force and the disturbing force becomes opposite to each other. The answer will be 180. Can you answer this question, guys? Next 2 questions in front of you. Question number 36 and 37. Alan, all books are good. Fluid Mechanics, R.K. Bansal is a very good book. P.K. Nag is also very good book for thermodynamics. Gate definitely you can crack by referring to any of the Indian author book, guys. There is no need to go through. Yes, for getting some kind of more understanding, you can refer to any of the book, foreign author book also. But there is no logic if and nobody can say ki yes, without referring to the foreign author book you cannot crack gate with very high score. It is not like that. Even there is no need. There are very good standard books are available for different subjects like fluid mechanics you mentioned. Okay, PK Nag is there for the thermodynamics. Okay, Ratan is there for theory of machine. Isinjan, Viganation is there. So lots of Indian author books are there, very good actually. NPTEL resources also there. You can refer to that. So don't worry about that. If you are referring to the Indian author books, definitely they are going to serve your purpose, and you will be able to crack the gate with very high score. But yes, you need to practice. After getting through the theory part, you need to practice more and more question. All previous year gate question and some kind of new question also you need to try. So if you are solving, like after studying theory from a particular chapter, and then if you are some kind of question practice book, suppose if you purchase from the market and you are getting a sectional question, like from thermodynamics, heat transfer, fluid mechanics, you are getting sectional question, like question from first chapter, second chapter, chapter wise question if you are getting, and then you are reading a theory part, you are practicing question, and if you are able to solve all previous year and new question, then yes, definitely you will be able to get good score. Don't worry. Door closer, they are designed with the critical damping, guys. Door closer, they are designed with critical damping. C is the answer for this question. In a spring mass system, if mass is halved and spring stiffness is doubled, the natural frequency. Guys, how much is the natural frequency? Omega n equal to under root k by m. Natural frequency of a spring mass system. So if you are having a spring mass system where k is the stiffness of the spring, okay, and m is the mass attached here, so the natural frequency will be what? Under root k by m. So what is saying? You are doubling the spring stiffness. Okay, if the mass is halved, mass को आपने क्या कर दिया? It is halved. Mass is halved, m by 2. Okay, and stream stiffness is doubled. What you will have? You will have, this is under root 4k by m. Under root 4k by m. So this is suppose omega n1, and this is what? This is 2 omega n1. So omega n2 will be what? Omega n2 becomes 2 times of the first. So for this question, it is going to what? It is going to double. B will be the answer for this question. Okay, mass is halved, mass को आपने आधा कर दिया, and stiffness you have doubled. Okay, then the answer will be what? B is the right answer, guys. Option B क्या हो जाएगा for 37th question? B is the answer. Let us move to next question, question number 38. There are some questions from the vibration part now. So in a spring mass system, 4 kg is the mass suspended to a spring of stiffness 100. What is the natural frequency? Circular frequency of the system in radian per second. So there are 4 options: 15 radian per second, 5 radian per second, 10 radian per second, and 4 radian per second. Guys, omega is nothing but under root k by m. So how much is the spring stiffness? The spring stiffness is this 100 Newton meter. How much is the mass? This is 4. So you will have under root 25. So this is 5 radian per second. So the natural frequency will be 5 radian per second. So option B क्या हो जाएगा? This is the right answer for this question. 5 radian per second. Let us move to next question. Question number 39. Please try to answer. Yes, vibration questions are comparatively easy. Mechanics के questions थोड़े difficult थे, but the vibration questions are comparatively easy. Thermodynamics heat transfer question also you are going to find out much direct. Okay, then some production question you are going to find out very good level question you are going to find out in the production part. So total 150 questions are there. Okay, next thermodynamics heat transfer, those questions are not going to take much time. The degree of freedom of a simple pendulum. Guys, simple pendulum ka how much is the degree of freedom? How much independent coordinates are required to define the motion of a pendulum, guys? Only 1. So degree of freedom of a simple pendulum is 1 only, guys. Degree of freedom of a simple single spring mass system, that is also 1. x1. So simple pendulum, simple spring mass system, they are having degree of freedom 1. Natural frequency of transverse vibration of a shaft carrying load at the center of the span. So there is a shaft which is carrying load at the center. So there is a shaft something like this. Let me take it here like that. So this is carrying some load at the center. So this is W. You know guys, natural frequency, or what you can say omega n, is equal to under root g by delta, where g is the acceleration due to gravity and this delta is the static deflection. This is the static deflection. Static deflection. Now, you know guys, the relationship between omega and f, omega equal to 2 pi f, where omega is the angular frequency in radian per second. This is the frequency in hertz. So Fn is nothing but 1 by 2 pi omega n. 1 by 2 pi omega n. So he is asking you this particular frequency. Okay. So if you will put it here, Fn equal to 1 by 2 pi, 2 into 3.14 under root what? G by delta. So G by delta. Delta is what? Delta is delta only. So you can put it here actually 1 by 2 into 3.14 and this is under root 9.81 divided by under root delta. Guys, if you solve this actually, if you solve this entire, you will get this very close to 0.4987. So there is a mistake actually, and that mistake was there in the original paper also, guys. That mistake is there in the original paper also, guys. So don't worry, please correct this. There must be 0.4987, something like this. So that is a mistake, and that is there in the original paper also. Okay, so D is the right answer, but this correction you need to make in this case. Natural frequency in hertz, it will be 1 by 2 pi under root G by delta. That will come out 0.4987. Let us move to next question, question number 41. Which of the following is a trapezoidal thread? Acme, square, buttress, or metric? Which of the following is a trapezoidal thread? You know guys, Acme threads which are used in power screws, these are the trapezoidal threads. So answer for this question will be option A, Acme thread. These are trapezoidal threads mostly used in. Okay, so next question in front of you, question number 42. There is a car moving with the uniform acceleration traveling a distance of 450 meter in a 5-second interval and covers 700 meter in next 5-second interval. What is the acceleration of the car? What will be the acceleration of the car? So guys, if you use it here, very simple relationship. UT S, actually the distance traveled, S equal to UT plus half AT square. So suppose U is the initial velocity, S is the distance traveled. So in first 5 seconds, you are traveling a distance of 450 meters. So 450 equal to how much the time? 5. So 5U plus half A into 5 square. So this is the first equation we are having. What is the second equation, guys? In second interval, you are traveling a distance of 700 meter. So how much is the total distance travel? This 450 plus 700, this is a total distance travel in two intervals. 450 plus 700, the total distance travel will be 1150. And this is equal to what? How much is the time? Time is 10 seconds. So 10U plus half A into 10 square. This is second equation, guys. First distance 450 you are traveling in 5 seconds. Second distance 700 you are traveling in next 5 seconds. So the total distance travel is 1115 a time of what? 10 seconds. Solving this, you will get two equations. Let me write it here. 450 equal to 5U plus 25A square by 2. 1150 equal to 10U plus 50A square. It is 50A square. Okay, let me multiply this with 2. इसको मैं 2 से multiply कर देता हूँ. So you will have 900 equal to 10U plus 25A square. Solving this, you will get minus minus minus. This will be cancelled out. you will have 250 equal to 25 a square. So this will be 10. So a is what? Acceleration a. No, not a. This is a only, guys. I don't know why actually I'm writing it a square. This is not a square. Okay, this is only a. Please. Chaliye, this is only a, guys, because ut plus half at square. Time you put already. So this is 25a by 2 into 2. Okay, so yes. So this will be this only 25a. Solving this, what you will get, guys? You will get acceleration equal to 10 meter per second square. So what is the answer, guys? D is the answer for this question. Option D is the answer for this question. Alon, actually, for any competitive exam, you need to practice. Actually, these are actually the real practical experience you need to take. Okay, so please start practicing previous year question. You will get the exposure, you will get the idea. So there are two parallel and coplanar shafts. Guys, there are two shafts which are parallel. There are two shafts which are parallel and they're in the same plane. Two parallel and coplanar shafts, they are joined by what? They are joined by the spur gear, guys. So answer for this question will be what? The answer will be spur gear. There are two shafts which are coplanar and parallel. They are combined by they are joined by connected by the spur gear. Next question. Question number 44. The efficiency of self-locking screw jack. How much is the efficiency of self-locking screw jack? Yes, please try to answer. Guys, this is always less than 50%. Always less than 50%. So option A क्या हो जाएगा इसके लिए? This is the answer. The fatigue life of a part can be improved by. How you can improve the fatigue life, guys? Electroplating से, polishing से, shoot pinning से, heat treatment से. How we can improve the fatigue life of a part? Guys, shoot pinning we carry out. Shoot pinning we carry out to improve the fatigue life. So the answer for this question will be shoot pinning, option C. Okay. So for this question, the answer will be shoot pinning. Actually, we bombard a component with some kind of very small balls. Okay, and that is going to improve its fatigue life, because whatever cracks or kind of concentration, stress concentration, deformities are there in a particular component, those are going to improve. So mechanical properties of a particular component are going to improve if you are carrying out the shoot pinning. Electroplating, they're only going to protect the surface. Okay, heat treatment generally we carry out to improve the strength, but it is not going to improve the fatigue. Yes, for making a particular component ductile or tougher, you can carry out some kind of heat treatment, but shoot pinning is going to improve the fatigue life. The following is an anti-friction bearing. What do you understand by anti-friction bearing, guys? Which of the following is a anti-friction bearing? Anti-friction bearing, they will have some ball and rollers. Ball rollers are there in a anti-friction bearing. So D is the answer. Roller bearing, ball bearing, these are known as anti-friction bearing. Footstep, general bearing, these are not anti-friction bearing. Next question in front of you, question number 47. As per the uniform wear theory, brakes and clutch friction radius. Brakes and clutch friction radius, guys. Uniform wear theory में brake and or what you can say effective radius. Effective radius will be what? This is r plus r by 2. In case of uniform wear theory, the effective radius will be r plus r by 2. So answer is what? A. अब ये कुछ ऐसे क्वेश्चन है बच्चों जो अगर आपको याद है then only you will be able to answer. Okay, you need not to spend much time for these kind of question. Only you need to read, and if you're getting the answer, you need to click. Because you cannot spend time in driving these kind of things. You need to remember these for uniform wear case. Yes, next question. Starting friction is low in which case the starting friction is low? Hydrostatic lubrication, hydrodynamic lubrication, mixed or cement fluid lubrication, boundary lubrication. You know guys, the hydrostatic lubrication, the starting friction will be low. It will be least. So hydrostatic lubrication, the starting friction is low. So for this question, A is the right answer. Yes, from that also you can try. बिल्कुल आप सही सोच रहे हो. Because the effective radius will be r only. But here actually you are having this also ना. Dimension से तो ये गड़बड़ हो जाएगा. Okay. Dimensionally this is also right. This is also right. सिर्फ एक ही को रिमूव कर सकते हो ना आप. Yes विपिन. डायमेंशन से आप एक ही को रिमूव कर पाओगे. ओनली ऑप्शन बी, नॉट ऑल. क्वेश्चन नंबर 48, 49. So starting friction is low in case of hydrostatic lubrication. Abhi again a kind of actual question you need to remember. According to IBR, safety factor of rivet should be less than. Safety factor of the rivet should be less than 4 actually. Okay. अब कुछ क्वेश्चन है, those you can skip also in the examination if you are not getting. Otherwise you need to remember. According to IBR, safety factor of rivet should be less than 4. C is the answer for this question. Let us move to next question, guys. In case of single welded butt joint, how much is the thickness of the plate? You know, butt joint we carry out when the thickness is very small. जब thickness बहुत कम होती है, then only we carry out the butt joint. Okay, so usually the butt joint is provided when the thickness is in the range of 1 to 6 mm. Although there may be different type of butt joint. It may be with the kind of bevel you are providing, single V, double V, okay, single U, double U. So here he has not mentioned, he means we are taking a kind of square butt joint. Okay, simple butt joint we are taking, we are not taking any kind of V, double V kind of case. So although you can go with the kind of 10 mm thickness also, but it is not like that 8 to 10. 8 to 10 is definitely not right. Okay, 8 to 10 is not right because the minimum thickness is also less, because with the case of this kind of square butt joint, simple butt joint, the thickness is required to be lesser. So B is 1 to 6. This is looking more, you know, this is actually suiting the entire situation. Then B is the most appropriate case for this question. 1 to 6 mm. Although, you know, but I mentioned there are maybe different cases. A fluid is a substance. What is a fluid, guys? So now we are having some next 10 questions from the fluid part. A fluid is a substance that always expands. No, this is not fluid. This is a gas. Is practically incompressible. This is also not right because gases are compressible. Cannot remain at rest under the action of shear force. So C क्या हो जाएगा is the answer for this question. Option C is the answer. Pascal law states that. What is Pascal law, guys? In a static fluid, in a fluid at rest, the intensity of pressure in all the direction is same. So according to Pascal law, the intensity of pressure is equal in all the direction for a fluid at rest. So option B क्या हो जाएगा is the answer for this question. For a fluid at rest, the intensity of pressure is equal in all the direction, or if you are supplying, if you are providing some pressure at a particular point, that will be equally transmitted in all the directions. Now next question, guys, question number 53 in front of you. Specify which of the following must be fulfilled by the flow of any fluid. Which is going to be satisfied? Now please read and try to answer. I think this everyone you will be easily able to answer if you'll read and if you will go through this particular question. Specify which of the following must be fulfilled by the flow of any fluid: real or ideal, laminar or turbulent. What is required to be satisfied, guys? Guys, the continuity equation which is must you need to satisfy. If there is any fluid flow, the continuity equation is must going to be satisfied. Newton's law, because you are having Newtonian fluids also, you are having non-Newtonian fluids also. Okay, flow may be laminar also, turbulent also, but the continuity equation is must going to be satisfied whether you are having a real fluid flow, ideal fluid flow, laminar or turbulent fluid flow. The flow fluid through a pipe is laminar. When you will have laminar flow in a pipe, guys, what is the critical Reynolds number? What is the critical Reynolds number for pipe? 2000 for pipe. So if the Reynolds number is less than 2000, the flow is said to be laminar in pipe. If the Reynolds number is more than 4000, the flow is turbulent. And if the Reynolds number is between 2000 and 4000, the flow is said to be in transition. Means it is converting from laminar to turbulent. Viscous flow through pipes, the frictional factor. What is the frictional factor? Guys, frictional factor for the viscous flow, laminar flow के लिए, because laminar flow is also known as viscous flow. Laminar flow or viscous flow. So the frictional factor is 64 by Re. Okay, but frictional coefficient which is nothing but the frictional factor divided by 4. This is frictional coefficient. So frictional coefficient is frictional factor by 4. This is 60 by Re. So here actually he mentioned frictional factor, but there is no option given with 64 by Re. So that's why I'm correcting it here, because that mistake was there in the original paper also. So here must be what? Frictional coefficient. Frictional coefficient. So frictional coefficient is what? 16 by Re. 16 by Re, where R is the Reynolds number. Okay, so that mistake is there in the original paper. For viscous flow through pipes, the frictional coefficient is given by 16 by Re. Next question in front of you, question number 56. Reynolds number may be defined as what? What is the ratio? What is Reynolds number, guys? What is Reynolds number? Reynolds number tells us about what? The dominancy of the viscous forces to the inertia forces. Or what? Inertia forces to the viscous forces. Guys, when Reynolds number is very low, it means the flow is laminar. So you need to remember Reynolds number is nothing but the ratio of inertia force to the viscous force. So actually that also you need to correct, because they mention internal force. So there is no this you need to write it as inertia force. So C will be the right answer. So Reynolds number is the ratio of inertia force to the viscous force, and it is nothing but rho Vd by mu, or you can write it as Vd by nu, where V is the average velocity, D is the characteristic dimension, and nu is the kinematic viscosity of the fluid. So Reynolds number is the ratio of the inertia force to the viscous force. So I'm correcting it here because that mistake is there. Inertia force to the viscous force. The loss of head or energy due to velocity of liquid at the exit. Guys, if there is any fluid at the exit of the pipe, exit of pipe ke exit pe, how much is the head loss, guys? How much is the head loss at the exit? That is nothing but V square by 2G. Head loss at the exit, HL at exit, this is a minor loss actually. Head loss at the exit is nothing but V square by 2G. So D is the answer for this question. Now question number 54 in front of you, guys. 58, sorry. 58. In turbulent flow, the frictional factor F for smooth pipe. Frictional factor for smooth pipe depends on, guys, for laminar flow, it depends on only Reynolds number. Now he has given you what? Different cases, Reynolds number and relative roughness for the case of smooth pipe. Turbulent flow, smooth pipe. So the flow is turbulent. Okay, the flow is turbulent, but the boundaries are smooth. Guys, actually, for this case also, it is going to depend only on the Reynolds number, guys. It is only going to depends on the Reynolds number. For turbulent flow with rough boundaries, Turbulent flow with rough boundaries, it is going to depend on what? The Reynolds number and surface roughness. Okay, but for this case, this is only going to depend on what? On the Reynolds number. Okay, guys, how much is this for laminar flow? F equal to 64 by Re. This is for what? Laminar. This is for laminar. How much is this frictional factor? This is 0.316, close to that, divided by Re ki power 1 by 4. This is for turbulent flow with smooth boundary. Turbulent flow with smooth surface. So with the turbulent flow also, smooth surface, the frictional factor depends only on Re. So D is the answer, guys. But if you are having turbulent flow with rough boundaries, then it is going to depend on what? Reynolds number and relative roughness. Then A will be the right answer, guys. So there are three cases. Laminar flow, it is going to depend on only Reynolds number. Turbulent flow, smooth surface, again it is going to depend only on the Reynolds number. But if you are having turbulent flow, rough boundaries, then it is going to depend on Reynolds number as well as relative roughness. Next question now in front of you, question number 59. So now I think we are having question from what? Heat transfer. The concept of boundary layer is introduced by, guys, this we are having a Prandtl boundary layer theory introduced in 1904 by Prandtl. So boundary layer concept is given by Prandtl, guys. Boundary layer concept given by Prandtl. So for 59 question, A is the right answer. Next question in front of you. The equation of capillary rise or fall of a liquid H equal to the theta for water. Guys, capillary rise, capillary rise or fall, we write it as 4 sigma cos theta by WD or rho GD. So this is the formula we are having. Now he is asking you what is this theta for water. Guys, actually for theta for pure water in contact with glass tube, theta for pure water in contact with glass tube is 0, but theta for ordinary water. Theta for ordinary water, guys. For ordinary water, this is close to 29 degree. Okay. The angle of contact angle will be 29 degree. Guys, if this contact angle, this question can be asked, contact angle less than 90, that fluid is known as what? Wetting. Usko hum kya bolte hain? Wetting fluid. This is wetting fluid. Okay. And if this contact angle is greater than 90, those fluids are known as what? Non-wetting. Like mercury. So mercury is a non-wetting fluid. So for water, pure water, the angle is 0 degree because there is no option given with 29. 29 के साथ कोई option नहीं दिया. That's why we can go with 0. Okay. Then we can go with 0 as the answer for this question. Now let's move to next question, question number 61. The product of Reynolds number and Prandtl number, guys. What is that product of Reynolds and Prandtl? Guys, the product of Reynolds and Prandtl, that is known as Paclet number. Guys, there is a number also, Stanton number, which is nothing but the ratio of Nusselt number to the Reynolds into Prandtl. So this is nothing but Nusselt into Paclet number. Guys, less is the Paclet number if it is less. Okay, then the Stanton number will be more, the heat transfer will be more, H will be more. So the product of Reynolds into Prandtl, this is known as Paclet number. Option A क्या हो जाएगा आपका आंसर हो जाएगा. The product of Reynolds into Prandtl is known as Paclet number. The product of Grashof into Prandtl is known as Rayleigh number, guys. This is known as Rayleigh number. This is Rayleigh number. Okay. Paclet number is there in heat transfer also, and this number is there in the mass transfer also, guys. Let us move to next question, question number 62. The effectiveness of a heat exchanger is the ratio of the two heat transfer, which is defined as the ratio of what? What is effectiveness of a heat exchanger, guys? This is the ratio of what? This is the ratio of the actual heat transfer to the maximum heat transfer. So effectiveness of a heat exchanger is nothing but actual heat transfer Q actual to Q maximum, and this Q actual is nothing but m dot H Cph into Thi minus The, or you can write it as m dot C Cpc into Tce minus Tci. So this is Q actual. What is Q maximum? Q maximum is m dot Cp smaller, the small heat capacity rate, into the maximum temperature difference. Something like that. The hot is entering at Thi, hot is leaving at Tci. That is a maximum possibility which we can have. Hot is entering at Thi, leaving at the inlet temperature of cold fluid, or the cold is entering at Tci and it is leaving at the entry temperature of hot fluid. So this is the maximum temperature change we can have for the hot or cold fluid. Okay, and maximum temperature change will be there for the fluid with minimum heat capacity rate. Okay, a fluid which is having more heat capacity, more storage, for that temperature change will be lesser. So maximum temperature change will be there for fluid with minimums or lower heat capacity rate. That's why Q maximum will be this, and this is the actual heat transfer, and this ratio is known as effectiveness of heat transfer. So actual to maximum, this is the effectiveness. C is the answer. Next question, question number 63. The roof of a house. So let us consider a house, something like this. So this is the house. So the roof of a house are coated with some kind of shiny material. आपने बहुत shiny material लगा दिया बच्चों. Roof of a house are coated with shiny metal paint. Guys, if you are providing some kind of shiny metal paint, तो shiny metal paint का reflectivity क्या होगा? It will increase. More is the reflectivity, so absorptivity is going to decrease. Yes or no? More is the reflectivity, absorptivity will be less. And if absorptivity is less, means lesser heat penetration will be there inside the room. So if you are providing some kind of shiny coating over the surface, then the room temperature is going to fall, guys. Room ka temperature kya ho jayega? It is going to fall. D is the right answer, guys. Let me ask you one more question. Guys, suppose if you are having a foil paper, aluminum foil, it is having suppose two sides. This is the shiny side, and suppose this lower one is the rough side. So if you want to wrap a hot item, you want to protect the heat transfer from a hot item, which side you will keep inside, shiny or rough? And again, if you want to wrap a cold item like some kind of ice cream, then which side you will keep inside, shiny or rough? Please try, please think and try to answer. The roof of a house has been given a coating, then definitely the reflectivity will increase, absorptivity is going to decrease, because the sum of absorptivity, reflectivity plus transmissivity is equal to 1. So if reflectivity is increasing, then definitely absorptivity is going to decrease. So lesser heat is going to enter inside the room. So the room temperature is going to decrease. Try to think about this also. Let us move to next question, question number 64. Which of the following does not pertain to transient heat conduction? Which of the following does not pertain to transient heat conduction? Guys, Bayes number, Fourier number, all are related to transient heat conduction. Hausdorff chart also is associated with the transient heat conduction, because if Bayes number is greater than 1, lumped analysis not applicable. Lumped analysis not applicable. Then we go with some kind of, what you can say, graphical method. Okay, you know guys, Bayes number, if it is less than 0.1, Bayes number kya hai? If it is less than 0.1, or what you can say, if the internal conduction resistance are less than 10% of external convection resistance. Internal conduction resistance are less than 10% of the external convection resistance. Means the internal conduction resistance is much lower, Bayes number is less than 0.1, then at a particular instant of time, you can assume everywhere temperature same. That is known as lumped mass. Okay, so all these numbers are associated with transient heat conduction, but there is no such factor, interchange factor. So D kya ho jayega is the answer for this question. Let us move to next question, question number 65. In free convection heat transfer, guys, next questions are theoretical only. Most of the question, like question from thermodynamics, heat transfer, production. Okay, so definitely next 1.5 hour or 1 hour we will be able to complete all 150 question. In free convection, transition from laminar to turbulent. Guys, in free convection, you know, there is a number which is known as Rayleigh number, which is nothing but the product of Grashof into Prandtl. So if this for a case of vertical plate, so if you are having a what, this Rayleigh number greater than 10 की power 9, तो flow क्या हो जाता है आपका, turbulent. If this Rayleigh number is less than 10 की power 9, the flow is what, laminar. So in free convection also we will have the flow. Flow may be laminar also. Flow may be turbulent also. Okay. Flow may be turbulent also. So that depends on what? That depends on the Rayleigh number. Okay. So answer for this is what? Rayleigh, and Rayleigh is nothing but the product of Grashof into Prandtl. So D क्या हो जाएगा is the answer. So in case of free convection, the nature of the fluid flow is prescribed by the number which is known as Rayleigh number. In case of forced convection, Reynolds number tells us about the nature of the fluid flow. Reynolds number tells us about the nature of the fluid flow, laminar or turbulent in case of forced convection, and Grashof number tells us about the nature of the fluid flow in case of free convection. Next question, question number 66. Absorptivity is equal to emissivity. You know, guys, there is a law. There is a law in radiation. A good absorber is also a good emitter. Good absorber is also a good emitter. That is what? That is Kirchhoff's law. That is the Kirchhoff's law. For what? For a body in equilibrium. For a body in thermal equilibrium. So if you are having a body which is in thermal equilibrium with its surrounding, then absorptivity equal to what? Emissivity. So the answer for this question will be what? Under thermal equilibrium condition, guys. So under thermal equilibrium condition only you can say absorptivity equal to emissivity. Next question, 67. These kind of questions are also there. What is LMTD? LMTD is nothing but a logarithmic mean temperature difference. LMTD. For a heat exchanger is nothing but temperature difference between hot and cold at x equal to 0, temperature difference between hot and cold at x equal to L divided by ln of theta 1 by theta 2. So what is theta 1? Theta 1 is the temperature difference between hot and cold. Let me take a case of what? A counterflow heat exchanger. So this is THI, this is THE, this is TCI, this is TCE. So this is x equal to 0, this is x equal to L. So theta 1 is the temperature difference between hot and cold at x equal to 0. This is theta 1. Theta 2 is nothing but the temperature difference between hot and cold at x equal to L. And this theta 1 minus theta 2 divided by ln of theta 1 by theta 2, this is known as logarithmic mean temperature difference. The formula is same for both parallel and counter, but the value will be different. Okay. For the same inlet and exit condition, the LMTD of counter is always more than LMTD of parallel. If the inlet and exit conditions of the temperature, fluid, hot and cold fluid are same, LMTD of counter will be more. That's why if counter flow and parallel flow heat exchanger you are having of the same area, the heat transfer will be more in the counter. Or if you are having what? Same area of what this parallel and counter flow. Okay, or what you can say, if LMTD is more, the area, if it is same, then heat transfer will be more. And if you are having heat transfer same, then area required for the counter flow heat exchanger will be lesser. You can have two cases. LMTD is always more for counter flow, and you know, guys, Q equal to UA delta TM. So in general, for the same inlet condition, delta TM counter is always more than delta TM parallel for same inlet and exit condition. For same inlet and exit conditions. That's why if this is more, so if you are having a case of what? Same area of parallel counter, then heat transfer in counter will be more. Or if you are having same heat transfer, then area required in the counter will be lesser as compared to the area required in parallel. So that's why for same heat transfer, counter flow heat exchanger will be much compact as compared to the parallel flow heat exchanger. So for this question, the answer will be what, guys? Theta 1 minus theta 2 by ln of theta 1 by theta 2. A ही क्या हो जाएगा? आपका आंसर हो जाएगा. Next question, 68. In a counterflow heat exchanger, cold fluid enters at 30, leaves at 50. Hot fluid enters at 150, leaves at 30. So if you will draw the temperature profile, it will be something like this. Counterflow heat exchanger, hot is entering at, cold is entering at 30. It is leaving at 50 degrees Celsius. This is cold fluid. Cold is lower one because heat is going to transfer from hot to cold. This is the heat transfer. Definitely, always upper fluid will be what? Hot fluid. Hot is entering at 150 and it is leaving at what? It is leaving at 130 degrees Celsius. So how much is theta 1, guys? Theta 1 is 150 minus 50, it is 100. How much is theta 2? That is also same. And in case of counterflow heat exchanger, if theta 1 is equal to theta 2, then delta Tm equal to theta 1 or equal to theta 2. In case of counterflow heat exchanger, guys, in case of counterflow heat exchanger, if theta 1 is equal to theta 2, then theta 1 or theta 2 becomes what? Lmtd, and you will have two parallel lines. So C is the answer for this question, 100 degrees Celsius. Please try to answer this next question in front of you, question number 69. Forced convection in a liquid bath is caused by. Forced convection in liquid bath is caused by density difference. क्या फोर्स कन्वेक्शन डेंसिटी डिफरेंस की वजह से होता है? नहीं. मॉलिक्यूलर एनर्जी इंटरेक्शन से होता है. देखो डेंसिटी डिफरेंस की वजह से तो फ्री कन्वेक्शन होता है. दिस इज फ्री कन्वेक्शन. मॉलिक्यूलर इंटरेक्शन की वजह से तो क्या होता है? दिस इज फ्री कन्वेक्शन गाइस, नॉट कंडक्शन. दिस इज फ्री कन्वेक्शन, सॉरी, दिस इज फ्री कन्वेक्शन. मॉलिक्यूलर इंटरेक्शन से क्या होता है? कंडक्शन होता है बच्चों, नॉट कन्वेक्शन. फ्लो ऑफ इलेक्ट्रॉन से भी क्या होता है? कंडक्शन होता है. फ्लो ऑफ इलेक्ट्रॉन, मॉलिक्यूलर इंटरेक्शन, कंडक्शन. डेंसिटी डिफरेंस से फ्री कन्वेक्शन होता है. इंटेंस स्टीयरिंग बाय एक्सटर्नल एजेंसी, यस, दैट इज गोइंग टू कॉज द फोर्स कन्वेक्शन. सो डी क्या हो जाएगा? आपका आंसर हो जाएगा. D is the answer for this question. Let us move to next question, question number 70. The value of extensive properties essentially depends on. Extensive property क्या होती है बच्चों? Any measurable characteristic of the system that is known as property. So properties are of two types, extensive, intensive. What are extensive? The property which depends on the size or mass of the system. Size means extent. What are independent? Intensive property. Intensive property are the properties which are independent of the size or mass of the system. So extensive property are what? They depend on size or mass. What are the example? Like all energies, kinetic energy, potential energy, mass, volume, all are extensive property. Temperature, pressure, thermal conductivity, density, viscosity, all these are intensive properties. Okay, chaliye, let us move to next question, question number 71. The process of converting ice directly to steam. Guys, you are converting solid to steam, guys. Solid से steam बना रहे हैं तो solid से क्या बना रहे हो? Vapor. So the conversion from solid to vapor is known as what? Sublimation. So sublimation is the process of converting solid directly into vapor. Solid to liquid, that is what? Liquefaction. Liquid to solid, that is solidification. Liquid to vapor, that is vaporization. Vapor to liquid, that is condensation. Solid to vapor is directly what? Sublimation. Next question. The gas with highest value of adiabatic index. What is adiabatic index, guys? That is gamma, and that gamma is nothing but the ratio of specific heat at constant pressure to the specific heat at constant volume. Gamma is the ratio of Cp by Cv. You know, guys, how much is gamma for air? Gamma for air is 1.4. How much is gamma for monoatomic gases? For monoatomic gases, this is in the range of 1.67. Gamma for diatomic gases, diatomic or polyatomic gases, this is air or what? Diatomic. Air or kind of diatomic gases, this is 1.4. For polyatomic, kind of exhaust gases like CO2, this is close to 1.3, 1.33. So for monoatomic gases, it is highest 1.67. For diatomic gases, it is 1.4. For polyatomic gases, it is 1.3. So helium is a monatomic gas. So this will be highest for what? Helium. So A is the answer for this question, guys. A क्या हो जाएगा is the answer. Let's move to next question, question number 73. The gas at pressure P in a vessel is compressed suddenly to half of its original volume. So there is a gas in a pressure vessel. So suppose this is some particular case. So this is at a pressure P. The volume is what? V. Now you compress this. आपने इसको क्या कर दिया? Compressed कर दिया. You compress this to half of its original volume. So this is V by 2. This is P1. This is P2. Okay. P1 is the initial pressure. P2 is the final pressure. So initial pressure is P1. Initial volume is V1. The final volume is V by 2. The final pressure is P by 2. Now he's asking you what after a long time matlab when you're going to compress, the temperature is going to increase. But if you're allowing this system for a long period of time, it is going to reject heat to the surrounding only, because it will become in equilibrium with the surrounding. So it will become again equilibrium. So temperature initial you can consider equal to temperature final. Although the compression process is not an isothermal process. This compression is not isothermal, but the initial temperature, final temperature are same. And if initial temperature, final temperature are same, then you can write it here P1 V1 equal to P2 V2. So P1 is what? P1 is P. This initial volume is V. The final pressure we want to find out. The final volume is V by 2. Okay. So this will cancel out. The final pressure will be 2 times of the initial pressure, means P2 equal to 2P. So B क्या हो जाएगा? आपका आंसर हो जाएगा. Yes, let us move to next question. Question number 74. The entropy of universe. You know, guys, there is a second law of thermodynamics which tells us about what? The entropy of the universe is always going to increase in any irreversible process. There must be entropy generation. Entropy is going to generate in a real process. Exergy is going to degrade in a real process. Energy is always going to remain conserved. Energy is constant. Entropy is going to increase. Exergy is going to decrease in a real process. Okay, so entropy of the universe is keeps on increasing. It will become maximum. So it is not going to become zero. It is not going to remain constant. It is moving in the direction of what? To make itself maximum. Entropy of the universe tends to become what? Maximum. Attain a certain finite minimum value. This is not right, because we are moving in what? Entropy change of the universe means entropy change of system plus entropy change of surrounding. This will always greater than equal to 0. Okay, system entropy in a process can increase or decrease. Surrounding entropy also in any process, whether the process is reversible or irreversible, system entropy also can increase, decrease. Surrounding entropy also can increase, decrease in any real process. But the collective entropy, the total entropy of system plus surrounding, or what you can say net entropy change of system and surrounding, that will be always positive. It can remain constant if you are carrying out some reversible process, or it will be always positive. Entropy of universe can never decrease. That is second law of thermodynamics. Which air standard cycle consists of two isothermal connected by two constant volume process? So can you answer this question, guys? So there is a cycle which is having two constant volume process. It is looking like very similar to Otto cycle. It is very similar to Otto cycle, but there is a difference. These are the two isothermal processes, and these are two constant volume processes. These are two constant volume constant. So 1, 2, 3, 4. So this is a cycle diagram on what? PV diagram. ब्रेटन में तो दो कांस्टेंट प्रेशर होते हैं बच्चों, टू कांस्टेंट प्रेशर, टू आइसेंट्रोपिक. एरिक्सन आल्सो टू कांस्टेंट प्रेशर, टू आइसोथर्मल. एरिक्सन, स्टर्लिंग, कार्नोट, these are three reversible cycle we are having, complete reversible cycle. Whereas Brayton cycle, Otto cycle, diesel cycle, these are partially reversible cycle. They are known as air standard cycle. So this is what? This is a Stirling cycle. Stirling cycle, which is used in a Stirling engine, 1 to 2 isothermal compression, then you will have constant volume, then again isothermal, then again you will have constant volume. So 2 isothermal, 2 constant volume. Okay. Next question, stainless steel contains following element. So this is actually a common sense question, guys. Just आपको देखना है, option देखना है आपको, and easily you will be able to conclude some answer, guys. Please read this, try to answer. स्टेनलेस स्टील में क्या क्या होता है बच्चों? देखो, स्टेनलेस स्टील में डेफिनेटली क्रोमियम होगा. क्रोमियम होगा डेफिनेटली. स्टील है तो कार्बन भी होगा. देन हाउ यू कैन हैव क्रोमियम आयरन विदाउट कार्बन? कार्बन तो देयर मस्ट बी कार्बन इन द स्टेनलेस स्टील. ओके, तो आयरन भी होगा. सो क्रोमियम, आयरन एंड कार्बन. So C is the right answer, guys. In stainless steel, you know, minimum 10% is there. Chromium, 10% minimum chromium is there in stainless steel. Okay, but iron and carbon, these are there in any of the stainless steel. Okay, how much is the maximum percentage of carbon, guys, in stainless steel? Maximum percentage कितना हो सकता है कार्बन का? That is usually less than 1.2%. Chromium का minimum 10 होना चाहिए. This is minimum 10%. And this is maximum 1.2%, close to that. Next question, question number 77. The binding material for cemented carbide. You know guys, cemented carbide, these we use as the tools. इनको हम as a tool use करते हैं. Sintered carbide, also known as sintered carbide. So these we use as a tool. Okay. So what we use as a binding material for cemented carbide? Cobalt we use as a binding material, guys. So D is the answer for this question, guys. Cobalt को use करते हैं for making some kind of sintered cemented carbide tool. Okay. Just to kind of carrying out the machining of very hard material, we use these kind of tools, cemented carbide, which is bounded or sintered by cobalt. Fastest method of hardening a sample. 78th question. Fastest method at case hardening. Which of the method is the fastest method for case hardening, guys? Case hardening के लिए कौन सा method है जो fastest है? What you will say, guys? Cyaniding is a method which is very fast and quick. So you can answer for this question cyaniding. Cyaniding. Try to answer next question also. Question number 79. 79. Guys, actually cyaniding, because directly in a solution of sodium cyanide, you dip the material, okay, and then you carry out the quenching in some kind of oil or water bath. So that's why cyaniding is much faster. Induction hardening is not a faster process for carrying out the case hardening. Cyaniding may directly to immerse the workpiece into the bath of sodium cyanide, okay, at a particular temperature in the range of 850 to 950 degrees Celsius, and then you need to carry out the quenching. That's why cyaniding is a very fast process to get the case hardening. Ose tempering produces. What is the answer for 79th question? Question number 79. Ose tempering producing. Guys, actually, tempering से हम क्या करते हैं? We try to get the hard surface and tough core. Ose tempering, we don't go with the tempering because that is additionally going to increase the process, and the cost of getting that hard surface or tough core is going to increase. Okay, so ose tempering is another method by which we can get some kind of hard surface and tough core. In ose tempering, austenite, that is going to convert into what? Ose ferrite. Okay, and with that we will get a very hard and tough core. 79th का ये होना चाहिए आंसर. Let us move to next question. Question number 80. In cold working, material gets stronger due to cold working में, when we carry out some kind of strain hardening. Strain hardening क्यों होता है बच्चों? Strain hardening is due to what? कोल्ड वर्किंग में स्ट्रेंथ बढ़ जाता है ड्यू टू व्हाट? स्ट्रेन हार्डनिंग. और स्ट्रेन हार्डनिंग किस वजह से होता है? दिस इज ड्यू टू व्हाट? डिसलोकेशन मल्टीप्लिकेशन. नंबर ऑफ डिसलोकेशन मल्टीप्लिकेशन की वजह से क्या होता है? आपका वर्क हार्डनिंग होता है. सो कोल्ड वर्किंग में मटेरियल गेट स्ट्रॉन्गर ड्यू टू डिसलोकेशन मल्टीप्लिकेशन. सो दिस इज द आंसर. डी इज द आंसर फॉर दिस क्वेश्चन. How many neck appeared? अब this is actually a kind of question which you cannot expect. अब direct question आ गया है कुछ ऐसा. But I feel answer will be one only. How many necks appear during tensile test of a specimen prepared according to ASTM standard? So answer will be 1. Next question, Gibbs phase rule. What is Gibbs phase rule for binary phase diagram? Okay, he has mentioned binary phase, but the formula is given very direct. Guys, what is phase rule? F plus P, the degree of freedom, number of phases, that is equal to C plus 2. This is number of components. So F plus P equal to C plus 2. So A is the right answer because he has not given any such kind of data. Okay, this is not right. This is also not right. This is also not right. You can check it here. So F plus P equal to C plus 2. This is Gibbs phase rule. So this we use to find out the degree of freedom, number of independent intensive properties which you can vary. Okay, or number of independent intensive coordinates required to fix the state of a system, that is known as degree of freedom. Next question 83. So now we are having some question from production part. चिप फ्लोज ओवर रेक फेस इज, बच्चों जब चिप फ्लो करता है रेक फेस के ऊपर, समथिंग लाइक दिस, सपोज यू आर हैविंग ए cutting tool, something like that. Let me take it here, a case. Okay, so suppose this is the workpiece you are having. तो इसमें जो शुरू वाला जो जोन बनता है बच्चों, फर्स्ट जो जोन होता है वो कौन सा जोन होता है? वो आपका स्टिकिंग जोन होता है. फर्स्ट जोन क्या होता है? आपका स्टिकिंग जोन होता है. एंड देन यू विल हैव व्हाट? स्लाइडिंग जोन. दो जोन्स बनते हैं बच्चों, स्टिकिंग एंड स्लाइडिंग. Sticking and sliding. So answer for this question will be sticking and sliding model. Chip flows over rake face is a kind of sticking, not stigmat. This is sticking. Sticking and sliding motion. Discontinuous chip. Continuous chip कब मिलते हैं बच्चों? Continuous chip we get for the case of ductile material when you are carrying out their machining with very high speed. Ductile with high speed will get a continuous chip. Continuous chip. But if you are carrying out the machining of brittle material with very low speed, then you will get what? Discontinuous chip. Discontinuous chip we will get for the machining of brittle material with low speed. Continuous chip we will get for the machining of ductile material with very high speed. In this question, he is asking you discontinuous chip during machining forms in the case of brittle material with very low speed. In grinding wheel, when the bonding agent is strong, guys, bonding agent is strong means the wheel is very hard wheel. उसको हम क्या बोलते हैं? बहुत हार्ड व्हील है. बॉन्डिंग एजेंट इज वेरी स्ट्रॉन्ग, हार्ड व्हील. सो अपॉन ग्राइंडिंग हार्ड मटेरियल्स, you are grinding very hard materials, strength is very high, hard wheel you are having. Slowly all the abrasive wears out and the grinding wheel is rubbing over the work piece without cutting. This phenomena is known as what? Guys, actually when this is going to happen, the abrasive are going to what? They are going to, they are going to become a kind of glass like, mirror like finish they are going to give, and that phenomena is known as actually glazing of the grinding wheel. Okay, glazing. Loading is what? Loading is the a kind of phenomena when the between the abrasive particle, between the different abrasive particle of a wheel, if some kind of material, workpiece material is getting deposited, if the workpiece material is deposited between the abrasive particles, that is known as loading. Okay, dressing, truing is related to what? A kind of sizing of the grinding wheel. Dressing is the process in which we remove the worn out abrasive particles. So dressing we carry out just to remove the worn out grits, worn out abrasive particles. That is known as dressing. Truing we carry out just to shape or sizing of a grinding wheel. Loading is a phenomena when grinding wheel is loaded with the material, workpiece material, due to the grinding of a very soft material. So if you are carrying out grinding of a very soft material, that soft work material will be loaded into the grinding wheel. That phenomena is known as loading. But if the wheel is very hard and you are carrying out grinding of a very hard material, then the grit, what you can say, those grinding wheel, those grit, they are going to wear out, abrasive particle, they are going to wear out, and they will start giving some kind of glass like, mirror like finish. That phenomena is known as glazing. Next question in front of you, question number 86. For unconventional machining process, following is the decreasing order at tool wear. Tool wear सबसे कम किस में होगा बच्चों? For unconventional machining process, tool wear will be lesser in which case? USM, ultrasonic machining, electric discharge machining, okay, electrochemical machining, या क्या है? Yes, electrochemical. This is ECM, electrochemical. तो mistake है थोड़ा सा. This is ECM, electrochemical machining. Guys, in USM, ultrasonic machining, the tool wear will be least. Okay. Electric discharge, electric chemical, although in all these they are all kind of non-conventional, unconventional machining processes, so tool wear will be least. But in out of these three, the USM will have least tool wear. So A is the answer for this question. The accuracy of machining in abrasive jet machining. Abrasive jet machining में with the increase in standoff distance. Guys, the distance between the workpiece, suppose this is workpiece, and the distance between the jet. Okay, so this is jet. This is what jet. The distance between the jet and workpiece, this is known as standoff distance. इसे हम क्या बोलते हैं? Standoff distance. The distance between the jet and workpiece, this is known as standoff distance. Guys, if you are keeping this very high, much distance, then also the accuracy of machining will be less. If you are keeping this jet very close to this, then also the accuracy is not that much good. So if you are keeping this jet close to the workpiece, the accuracy is going to increase. But again, it will start decreasing. So C क्या हो जाएगा? आपका आंसर हो जाएगा. You know, to maintain some kind of optimum standoff distance, some optimum distance you need to maintain so that the accuracy will be good. Initially, if you are moving the jet towards workpiece, means if you are increasing the standoff distance, or if you are moving it away, then initially standoff distance, if you are increasing, the accuracy will start improving, but again it will start decreasing because the jet is going far away from the workpiece. Okay, so initially it is going to increase and then it will start decreasing. So for this question, C is the answer. Okay, next question move करते हैं, question number 88. Guys, this question you can try. I'm putting it here in front of you. I will also provide you some idea about this. Larger clearance angle are used in drills to machine ductile material, because ductile material have tendency for, guys, you know, for machining of ductile material, we go with some kind of larger clearance angle. Point angle also we keep larger. Point angle we keep larger for ductile material. Clearance angle and point angle. Point angle, clearance angle, दोनों क्या रखते हैं हम? लार्ज रखते हैं बच्चों. किसके लिए? फॉर डक्टाइल मटेरियल. डक्टाइल मटेरियल के केस में क्या होता है बच्चों? दे आर, यू नो, द चिप फॉर्मेशन विल बी मच हायर. चिप फॉर्मेशन बहुत ज्यादा होता है. ओके, एंड दे आर what they are having ability, they are tougher. So the answer for this question will be C, I feel. Larger clearance angle are used in drilling. Point angle we keep larger for ductile material due to the higher chip formation. Higher chip formation. For brittle material we keep smaller point angle. So I feel the answer for this question will be C. Okay. Chip formation, yes, chip formation. Chip formation is higher. So this may be the also answer. D may be. Okay, so there is a confusion between this and this. We can check. 88. I'm not very sure whether it is good to give this or this, but both can be the answer. These are not right. Elastic recovery or malleable. Okay. They are having high chip formation, tough or larger inclusion and larger elongation. Both are looking good. B may be slightly better to answer for this question. Okay, but later stage I will confirm which one will be good to answer for this question, guys. Next question in front of you, question number 89. Fastest method for producing gear. Which of the method is the fastest method for producing gear? Gear production के लिए बच्चों, which one of the is the fastest method? You know, guys, gear hob is a multi-point cutting tool by which we can directly cut gear. So gear hobbing is the fastest method for cutting gear. So C is the answer for this question, guys. Question number 90 in front of you. In 3-to-1 principle of jig design, 3 hemispherical pins are provided in base. Identify the wrong statement in this regard. 3-to-1 principle क्या करते हैं बच्चों? These are actually provided in jigs to, you know, restrict the movement of the workpiece. And actually it is going to restrict all the degree of freedom. It is going to restrict the motion, rotation in x, y and z direction. So you are going to restrict all degrees of freedom. Like it may be 12 if you will consider translation in x, y, z, both positive, negative, and rotation also if you will consider both clockwise and anti-clockwise, then degree of freedom will be 12, or in general case you can define the degree of freedom as 6. So I feel the answer for this question will be this, because it is going to ensure the machining in one plane. It is going to position the tool also, because jigs are used to guide the tool also. This he's not talking about here the picture jigs. Jigs are going to position the tool also. For heavier workpiece, we provide 3 hemispherical plugs. So I feel for this question the answer will be B. It is going to arrest 5 degree of freedom. This is not right. This is actually the wrong statement. This is the wrong statement. This is going to restrict. It is going to arrest all degrees of freedom. Sari ki sari 6 degree of freedom or 12 degree of freedom it is going to arrest. B is not right. Question number 91. In which of the welding technique weld pool is protected by inert gas? Inert gas किसमें use करते हैं बच्चों? In which case we use inert gas? Okay, submerged arc welding में नहीं, resistance welding में नहीं, in TIG welding yes. This is tungsten inert gas arc welding. Tungsten inert gas arc welding, we use inert gas to provide the inert atmosphere, to provide the just to safeguard the weld pool. So TIG is the answer for this question, guys. Next question in front of you, question number 92. In arc welding process, the current value is decided by. Current value को कौन decide करता है बच्चों in arc welding? Current value is decided by length of the weld pool, speed of the travel, voltage across arc, thickness of the plate, guys. Thickness of the plate. Based on the thickness of the plate, you are going to keep the current. So current is decided based on the electrode. Electrode is based on what? The thickness of the plate, or directly what you can say, based on the thickness of the plate you want to weld, the current value is decided. So A is the answer for this question. The problem of arc blow will be very serious in. You know guys, what is arc blow? Arc blow is what? It is a deflection of the arc. Deflection of the arc in case of arc welding. Okay. And this will be serious in which case? DC electrode positive. Electrode positive means this is a kind of reverse polarity. This is DC electrode positive, reverse polarity. DC electrode negative, this is the straight polarity. DC bare electrode or AC. In which case arc blow will be more. In which case the diffraction of the welding arc will be maximum. Okay. Arc blow का problem किसमें ज्यादा होता है बच्चों? The deflection of the arc blow will be maximum in case of DC with electrode negative, guys. This is straight polarity. So if workpiece is positive, then the deflection of the arc blow will be more. The arc blow problem will be more serious in case of DC electrode negative. B is the answer for this question, guys. Maximum reduction can be given to any material in tube drawing using. In which case you can give maximum reduction. Tube sinking. Next one is what? Drawing with floating mandrel, drawing with fixed mandrel, drawing with moving mandrel, guys. If you are using a moving mandrel, then the reduction will be more. Okay. Maximum reduction can be given if you are using a drying operation with a moving mandrel. Question number next 95 in front of you. The process in which during forging moves towards center. In which case the material will move towards center, guys. Edging, fullering, hubbing, or open die forging. In which case the material will move towards the center. I feel, guys, for this question the answer will be fullering. If you are using a fullering tool, okay, then the movement of the material will be there towards the center. I feel B will be the right answer. Edging, hubbing, or open die forging, the movement will not be towards center. Fullering, I feel, is the right, looking like answer, right answer for this question. Question number 96. In wire drying operation, the bright shiny surface on wire is obtained by. How you can get a very bright shiny surface on the wire? Not using a lubricant, using thin film lubricant, using solid lubricant, or good surface finish dye. Obviously, we need to use lubricant, guys, if you want to have a very good shiny surface. But what kind of lubricant? Solid or thin film? It is good to use thin film lubricant, guys. So if you are using thin film lubricant, then in wire drying operation, we will get very bright shiny surface wire. So B is the answer. Which of the following is used to hold cutter in milling machine? मिलिंग मशीन में कटर को कहां पे होल्ड करते हैं बच्चों? कटर कहां पे होल्ड करते हैं मिलिंग मशीन में? यू नो गाइस, मिलिंग मशीन में क्या होता है? आपके पास एक आर्बर होता है. यू नो, मिलिंग मशीन में क्या होता है? आपके पास आर्बर होता है गाइस, समथिंग लाइक दिस. लेट मी टेक इट हियर. सो ये क्या होता है आपका? दिस इज द मिलिंग टूल. दिस इज द मिलिंग टूल गाइस. ओके, सो इन दिस मिलिंग टूल, मिलिंग कटिंग टूल में ये क्या होता है आपका? दिस, व्हाट इज दिस? दिस इज द आर्बर. सो कटिंग टूल इज होल्डेड बाय व्हाट? आर्बर in milling machine. So next question, 98. Core in the centrifugal casting is made of. Core in the centrifugal casting. Centrifugal casting में core is made up of what? Carbon steel, core sand, wax, or no core used. Core in the centrifugal casting. Guys, in centrifugal casting we use any kind of core. Cores we use to provide some kind of internal cavity in case of sand casting. Okay, we don't use any core in case of centrifugal casting, guys. Centrifugal casting में we don't use any core. So D क्या हो जाएगा is the answer. Next question in front of you. A hole of 1 mm is to be drilled in glass. Guys, if you want to drill a hole in kind of brittle material में very small hole. Brittle materials में if you want to drill a very small hole, that is drilled by what? Ultrasonic. So USM, ultrasonic machining is the answer, guys. Don't go with laser. Laser in general we use for drilling very small holes. Okay, but ultrasonic machining किसके लिए करते हैं? For drilling in glass like brittle materials. So for drilling very small holes in brittle materials, we use ultrasonic machining. Next question in front of you, 100 question. The limit and fit system shaft basis is one whose. In limit and fit system, shaft basis system is one. What is shaft basis system in limit and fit system, guys? Shaft basis system क्या होता है? So in that case, shaft basis system, the upper deviation is what? What is upper deviation, guys? Try to think. 100 question in front of you. So upper deviation is 0. Shaft basis system में आपका upper deviation क्या होता है बच्चों? This is 0. B क्या हो जाएगा? Is the answer for this question. Question number 101. According to Taylor principle, no-go gauge checks. No-go क्या check करता है बच्चों? There are two gauges we use, go and no-go. Go, must go, and no is not required to be go. So this no-go gauge क्या check करता है बच्चों? No-go gauge check the what? Only one feature at a time, guys. No-go gauge एक ही feature को check करता है. Where go gauge check multiple features. Go gauge, because go is going to be go gauge is going to enter into the component, so that is going to check multiple features, but no go gauge is only going to check what? One feature at a time. So A क्या हो जाएगा is the answer for this question. Next question, question number 102 in front of you. So there is a tolerance of hole are shown in figure. So this size is 30, this size is 30. This is the lower division, this is 0.02. Let me write it here. This is 0.05. Maximum size of go gauge according to workshop design. Maximum size of go gauge. आपसे go gauge का size पूछा बच्चों. What is the maximum size of go gauge? So this you can write it something like this: 30 plus 0.05 plus 0.02. So how much is the tolerance, guys? Tolerance कितना हो जाएगा इसमें? How much is the tolerance? What is upper limit? Upper limit क्या है बच्चों? Upper limit is 30.0. How much is the lower limit, guys? This is the lower limit. So how much is the tolerance? This is the tolerance, guys. 0.03 is the tolerance. Okay, 0.03 is the tolerance in this case. Okay. Now, how much is the size of go gauge, guys? How much is the size of go gauge? The size of go gauge is nothing but lower limit of hole plus what kind of wear allowance, wear tolerance. Generally we take that as a 10% of the tolerance. तो अगर आप 10% of tolerance लेंगे, what is 10% of tolerance? 10% of tolerance is equal to, अगर मैं इसको 0.1 से multiply कर दूं, you will get what? This is 0.03. Okay, so this is 10% of tolerance. Size of go gauge is this, lower limit of hole plus 10% of tolerance. So this will be what? Lower limit of hole is what? 30.02 plus 0.003. So if you will add, you will get answer 30.023. So B is the answer for this question, guys. Please check. B क्या हो जाएगा? Not A. B is the answer. We need to go with some kind of standard rules, guys. You can take it as a lower limit also if you are not giving any kind of allowance. Okay, but minimum actually 10% allowance you need to give. 10% of hole tolerance allowance you need to give, guys. These are actually standard ISO standards. These are ISO standards. Okay, so this much allowance we need to give, 10% of the tolerance. So lower limit of hole plus 10% tolerance. This is the allowance we are giving, ISO standard. नेक्स्ट क्वेश्चन में मूव करते हैं, क्वेश्चन नंबर 103. रैपिड प्लेन इन एनसी मशीन. नाम से ही पता चल रहा है बच्चों, व्हाट इज रैपिड प्लेन? व्हाट इज रैपिड प्लेन? रैपिड प्लेन इन एनसी प्रोग्रामिंग इज, रैपिड प्लेन क्या होता है बच्चों? जहां पे आपका जो टूल है, टूल इज क्विकली गोइंग टू मूव टू द रैपिड प्लेन. So imaginary plane just above the workpiece, imaginary plane just below the workpiece, plane at which work is capped, plane at which tool changes, plane at which tool changes. You know guys, in a CNC or NC machine, we use tool. Okay. So at the rapid plane, the tool is going to move to that plane very quickly and we are going to change the tool. So at rapid plane, the tool is going to change. D is the answer, guys. Let us move to next question, question number 104. Power consumption in metal cutting is mainly due to. Power consumption क्यों होता है बच्चों? Metal cutting power consumption is due to tangential forces, longitudinal component of forces, normal component of forces, or friction at tool chip interface. What is the reason behind power consumption in metal cutting, guys? Guys, you know the force in the direction of the tool. Okay, suppose you are moving any kind of tool, so the force, or what you can say, tangential force. Tangential force क्या होगा? This is a component, the force component in the movement direction of the cutting tool. So that is what, that is a major cause of what? Power consumption in metal cutting. So tangential component of force is going to contribute into the power consumption in metal cutting. So A क्या हो जाएगा आपका? आंसर हो जाएगा बच्चों. Rake angle in twist drilling varies from center of the drill towards periphery. What is rake angle, guys? In drilling, this rake angle is also known as helix angle. This is also known as helix angle. So in case of drilling, something like this, if you will draw, you are having different fluids, something like this. So let me take it here, the central axis. Okay, and these are the fluids actually. So here this angle is what? This is the rake angle, guys. And this rake angle actually is always going to what? Decrease. If you check it here, this is rake angle or helix angle. Rake angle or helix angle, this is going to decrease continuously. So here if you'll check, this is the rake angle. Here if you'll check, this is going to decrease. So rake angle is going to decrease. So I feel the answer for this question will be what? D. In case of drilling, the rake angle is also known as what? Helix angle. And helix angle is going to decrease continuously. So I feel for this question, the option 4 will be the right answer. Okay. So this is the axis of drill, guys. This is axis of drill. This is leading cutting edge. Leading cutting edge. So angle between the leading cutting edge and the axis of the tool, axis of drill. So axis of the drill and the leading cutting edge, that angle is known as what? Helix angle or rake angle, or this is also known as spiral angle. Also known as spiral angle. Okay, and that spiral angle, helix angle, I feel it is going to decrease. So from this here, you can check it here. So this is going to decrease. So D is the answer. Let us move to next question. Question number 106. Actually, these kind of question you will find in case of engineering services examination. So engineering services examination में एक APT language से आपको question दे दिया बच्चों. L1 is expressed as APT. In this particular language, APT, L1, how you are going to represent L1? Guys, let me give you some hint, because this easily you can answer without knowing about this APT also. So this is X, this is Y. This is line L1, guys. This is line L1. So do you want to define this line L1? You want to define this line L1, guys. Okay, fine. So there are two circles given. So this circle is having center C1. This circle is having center C1. This circle is having center C2. So there is a line. There are two circles. This circle is having center C1. This circle is having center C2. Now, how you can express this line L1? So L1 is a line left of tangent to C1. Guys, this line is tangent to circle. This circle also. This line is tangent to both the circles. But this line is in right of this. इसके किस में है? Right में. And C2 के किस में है? Left में है. So now the answer will be what, guys? L1 is a line which is right of tangent C1 and which is left of tangent C2. So B क्या हो जाएगा? आपका आंसर हो जाएगा बच्चों. Option B will be the right answer. Please check it again. So this is a line. This is a line which is tangent to both the circles C1 and C2. These are the two circles. But what is the difference? This is tangent on the right of this C1, on the left of this C2. So L1 is a line which is right tangent to C1, which is left tangent to C2. So B क्या हो जाएगा? आपका आंसर हो जाएगा बच्चों. B is the right answer. Okay, so sometime you can try to answer these kind of question also. Okay, but some basic you need to read the entire question. If you will read the entire question, then definitely easily you will be able to get the answer. Next question move करते हैं. Question number 107. Diamond pin locators are used in fixture because. Why we use diamond pin locators in fixtures? Because they are just center to center distance between two holes, guys. Diamond pin locators को हम क्यों यूज करते हैं fixtures में? Because they adjust the center to center distance between two holes. B क्या हो जाएगा is the answer. Let us move to next question. Question number 108. Extrusion forces does not depend upon. Extrusion forces does not depend on what? Type of the extrusion process. Obviously, type of the extrusion process, extrusion forces are going to depend. Extrusion ratio also they are going to depend. Working temperature also they are going to depend. Is there any relationship of the extrusion process, extrusion forces with the material of the die? There is no relationship between the extrusion forces with the material of the die. That's why C is the answer, guys. Extrusion forces are not going to depend on material of the die. Extrusion forces are going to depend on extrusion ratio, types of extrusion process, working temperature. Which manufacturing process you use for manufacturing steel balls, guys? स्टील बॉल्स को हम किससे मैन्युफैक्चरिंग करते हैं? कास्टिंग, मशीनिंग, सिंटरिंग और कोल्ड हेडिंग. स्टील balls are manufactured by, yes, by cold heading we manufacture the steel balls. C क्या हो जाएगा is the answer. Next question in front of you, question number 110. Pinch effect in welding is a result of. Pinch effect. What is pinch effect, guys? It's the process of getting a very narrow and long flame. A process of getting a narrow and long flame. A process of getting very narrow and long flame. And this we get by the effect of what? Electromagnetic forces. B is the answer, guys. Due to electromagnetic forces, we get this pinch effect through which we get a very narrow and long flame. Next question, question number 111. Project completion time in PERT. Now we are having question from industrial part. You know, guys, in PERT, which type of distribution we use? Beta, normal, binomial or Poisonous? We use beta distribution in PERT. PERT में हम क्या यूज करते हैं बच्चों? We use beta distribution. A क्या हो जाएगा is the answer. Inventory control in production planning and control aims at. For what purpose we use inventory control? Inventory control किस लिए करते हैं? Achieving optimization, ensuring against market fluctuation, acceptable customer service at low capital investment in inventory, discount allowed in bulk purchase. What you will say, guys, for this question? Why inventory control is in production planning and control aims at? Production planning and controls mein why we go with the inventory control? Guys, you know, inventory, why you want to keep inventory? Just to satisfy the customer. So the acceptable customer service at low capital investment in inventory. So this is the aim of the inventory control. Optimization, there is no logic, no relation. Market fluctuation के लिए inventory नहीं रखते बच्चों. Market fluctuation can be there. Okay, we keep inventory for the acceptable customer service at low capital investment, so that we will be able to satisfy the customer also, and at the same time the investment, the inventory carrying cost will be lesser. Okay, then we can think of some kind of discounter also, but the main aim of inventory control is to acceptable customer service. C is the answer, guys. Which of the following is independent sales forecast? Which of the following is independent sales forecast? Independent sales forecast. इन्वेंट्री सेल्स इंडिपेंडेंट ऑफ आना चाहिए बच्चों. अभी ये ओरिजिनल पेपर में भी ऐसे ही था. यू कैन चेक द ओरिजिनल पेपर ऑल्सो. विच ऑफ द फॉलोइंग इज इंडिपेंडेंट ऑफ सेल्स फोरकास्ट? विच ऑफ द फॉलोइंग इज इंडिपेंडेंट ऑफ सेल्स फोरकास्ट? सेल्स फोरकास्ट पे क्या इंडिपेंडेंट है? इन्वेंट्री डिपेंड ऑन सेल्स फोरकास्ट. यस, सेल्स फोरकास्ट के ऊपर इन्वेंट्री डिपेंड करेगा. प्रोडक्शन प्लानिंग डिपेंड्स ऑन सेल्स फोरकास्ट. यस, डेफिनेटली प्रोडक्शन प्लानिंग इज गोइंग टू डिपेंड. प्रोडक्शन कंट्रोल इज ऑल्सो गोइंग टू डिपेंड ऑन सेल्स फोरकास्ट. बट the productivity is having no relation with the sales forecast, guys. Productivity is independent of sales forecast. So A is the answer, guys. Which of the following is independent of sales forecast? Productivity is independent of sales forecast. A is the answer. In CNC machining, Z axis represent. CNC machining में Z axis क्या represent करता है बच्चों? In CNC machining, Z axis represent what? Tool axis. वर्क एक्सिस होना चाहिए बच्चों. वीक तो गलत हो गया, वर्क होएगा. दिस इज वर्क एक्सिस. टूल एक्सिस, वर्क एक्सिस, टेबल एक्सिस, बोथ वर्क एंड टूल एक्सिस. सीएनसी मशीनिंग में जेड क्या रिप्रेजेंट करता है बच्चों? यू नो, जेड रिप्रेजेंट्स द टूल एक्सिस. इन सीएनसी मशीनिंग Z is going to represent, Z axis is nothing but the tool axis. In part critical activity. What is critical activity? Critical path. Critical path is the shortest path. Okay, where the zero float, there is the float is what? Zero. Critical activity पे the float is what? Zero. B क्या हो जाएगा? Answer हो जाएगा बच्चों. In part critical activity has zero float. In linear programming problem, if new constraint is added, if you are adding some new constraint in the linear programming program, so if you can write some linear programming problem, okay, you can write the objective function, okay, you can write the different constraints, something like this, you can write different constraints. Okay, so what is saying, like something like that, you are having some different constraints, you are having some objective function. So if you are introducing some new constraint, अगर आपने new constraint डाल दिया, so what is going to change? Feasibility, optimality, both feasibility and optimality. Guys, if you are introducing new constraint, that is going to change the objective function. New constraint is going to change the objective function. This is going to change what? This is going to change the what? Your bounded region. Okay, with the new constraint, if you are adding, that is going to change the bounded region. So I feel for linear programming problem, if you are adding some new constraint, that is going to change both feasibility and optimality. Both feasibility and optimality is going to change. I feel C will be the answer, guys. Next question move करते हैं. Question number 117. A network has 3 activities on critical path. So there are 3 activity on the critical path with mean time 386 and variance this. So this is the mean time. So how much is the expected time, guys? Expected time कितना हो जाएगा? This is 3 plus 8 plus 6. So this will be 17. How much is the probability to complete a particular project on 17 days only? तो किसी प्रोजेक्ट को 17 ही दिन में कंप्लीट करने की कितना प्रोबेबिलिटी है? सो हाउ मच इज दिस? व्हाट इज जेड, गाइस? जेड क्या होगा आपका? दिस इज टी माइनस टीई by sigma. T minus TE by sigma. So here you can check. This is what? Both T and TE are same. T equal to TE. The probability of finishing the project in 17 days. This is only what? Expected days. Okay. So what do you will get for this question, guys? You know, here, this is the expected time. And this expected time is equal to T. So Z you are getting what? You are getting Z 0. So the probability will be what, guys? 50%. It may be this. It may be this. The probability may be 50%. 0.5 or 50%. The probability of completing this project in 17 days is 50% because Z is coming out 0. Expected time equal to the project finishing time. So the probability of completing this project is 50%. Next question move करते हैं. If the demand of an item is doubled, you are doubling the demand and ordering cost half. What will be the change on the economic order quantity? If the demand of an item is doubled and ordering cost halved, then what will be the change in EOQ? So what is EOQ, guys? EOQ, economic order quantity, is nothing but under root 2D CO by CH. Where D is the demand rate, CO is the ordering cost, and CH is the holding cost, inventory holding cost. So here, what is saying? The demand is doubled. So 2 into 2D. Ordering cost is halved. Ordering cost क्या हो गया आपका? आधा हो गया बच्चों. So this will be what, guys? The EOQ is going to remain what? Same. Demand is doubled, ordering cost halved. The EOQ is going to remain same. So answer for this question will be what? A. Remain unchanged. A क्या हो जाएगा is the answer. Let us move to next question, 119. Simplex problem is considered as unbounded. when you will have unbounded simplex problem. Guys, simplex problem में unbounded कब मिलता है? जब all the variables in the entering column are negative. All the variables in the entering columns are negative, then we will get the unbounded solution in case of simplex problem. So A क्या हो जाएगा? आपका आंसर हो जाएगा. If you will recall about this simplex method, you will get all variables in the entering column are negative, then you will have unbounded solution. Next question, question number 120. A bank queue is having, there is a bank in which you are representing the queue. There are three counters. Okay, there are three counters with 30 system capacity caters to the whole campus. Whole campus means how much is the population? How much population you are catering? That is infinite. Okay, how much are the counter? There are three number of counters. How much is the calling population? How much population you are calling? 30. 30 is the system capacity. Okay, so if arrival rate is 10 per hour, service rate is 12 per hour, on first come first serve basis, FCFS, this is the system you are using. Okay, first come first serve system, then how you can represent that bank queue? How you can represent that bank queue? Okay, please try to answer, try to think. You know guys, this M, here you will have a number of counters. The system which you are using, what is that? First come first serve basis. Okay, then how much is the calling population? How much is the calling population, guys? That is 30. But how much is the capacity? That is infinite. Okay, so that is 30 into infinite. So how much is the calling population? 30. How much is the capacity? Infinite, whole campus. So the calling population, capacity. So the answer will be what, guys? MM. How many counters? There are three counters. First come first serve basis. Calling population is infinite. How much is the capacity? That is 30. Yes, no. The calling population is 30. Sorry. Calling population is 30. How much is the capacity? Infinite. So C is the answer, guys, for this question. Please check. C will be the answer for this question. Okay. Capacity, शायद मैंने पहले ठीक लिखा था. Calling population. Yes, capacity and then calling population. I think capacity and calling population. I think first, I think it will be something like this. It will be capacity and calling population. तो मैं यहाँ पे ठीक कर देता हूँ बच्चों. So it will be capacity and calling population. So this is capacity and calling population. So this will be the answer, guys. There is a small correction. So MM3 infinite 30. So I feel not C, B is the right answer, guys. Please check. B is the answer, guys. Please check. B will be right, not C. Okay. First, you need to write the capacity of the system. Capacity of the system is infinite. And how much is the calling population? That is 30. So FCFS infinite 30. B will be the right answer. Please try to answer the next question. Question number 120, guys. Tolerance are provided. Why we provide tolerance? Why we provide tolerance? Because machines are not accurate. Yes, it is very difficult to get very high accuracy with the machining. Yes, there are inaccuracies in machine, and due to that, we provide tolerances. Machining environment follows a normal distribution. Quality of fit will come only when there is a range, easy of manufacturing. Tolerance we provide, yes, because there are inaccuracy in the machining, guys. There are two major reasons for providing the tolerance. First, actually every time Ideal setting is not feasible, okay, because the operator, which is actually a kind of setting, carrying out some kind of setting on a machine, that is not possible. Every time he will be able to settle with some kind of ideal setting he will be able to provide, because that a kind of human factor is there. So that variation is there due to the operator efficiency in providing the ideal setting every time. At the second time, machine is also having some inaccuracies in developing the same component every time. So yes, the right answer for this is looking like A. Machines are not accurate. Okay, so then we can go with this particular answer. Next question in front of you. Question number 122. Earthquake produces the following type of vibrations. What kind of vibration we get from the earthquake? Torsional, transverse, seismic vibration. Yes. So from earthquakes we get what kind of vibration, guys? Seismic vibrations. C क्या हो जाएगा is the answer, guys. Earthquake produces the seismic vibrations. In part activity, time is considered as beta distribution, guys. In part activity, we go with the beta distribution because why we go with beta distribution in part? It is a unimodal. It cuts two intercept on axes. It is a continuous distribution, guys. Beta distribution is a continuous distribution. Part activity, time is considered as beta distribution because beta distribution is a continuous distribution. Okay. D will be the answer. Let us move to next question. Question number 124. The thermal efficiency, now we are having question from the power plant. The thermal efficiency of an ideal Rankine cycle is less than Carnot cycle, operating between the same maximum and minimum temperature limit, because guys, Rankine cycle is a kind of vapor power cycle, and a Carnot cycle is an ideal cycle. Carnot cycle efficiency depends on the temperature limit only. So why the Rankine cycle efficiency is lesser as compared to the Carnot cycle efficiency? What do you feel? What is the reason? Because heat addition does not take place at constant temperature. Expansion process is not reversible. Expansion, compression, both are reversible, adiabatic. Heat rejection does not take place at constant temperature. Rejection takes place at constant temperature, guys. If you will draw the Rankine cycle here, standard Rankine cycle, something like this. So this is the pumping process. Then you will have heat addition, something like this. You will have superheating, and then you will have a kind of rejection process, heat rejection, something like this. So this is what rejection. So rejection is at isothermal constant pressure. Actually, in Rankine cycle, we will have rejection at constant pressure, but that rejection is going to take place in the wet region, phase change. So both pressure and temperature are constant. Pressure, temperature, both constant. So rejection in Rankine cycle is isothermal. Okay, but addition is not isothermal. Addition किस पे होता है बच्चों? At constant pressure. In Rankine cycle, the addition takes place at constant pressure, rejection takes place at constant temperature. So what is the answer, guys? Addition does not take place at constant temperature. This is the right answer, guys. Option A क्या हो जाएगा? Is the answer. Thermal efficiency of, because Rankine cycle is not a reversible cycle, whereas the Carnot cycle, if you will draw, this is temperature versus entropy diagram. Same if you will draw it for the Carnot cycle, temperature versus entropy, you will have a plot like this. So this is TS plot for what? A Carnot cycle. Okay, this is what Rankine cycle. So in Rankine cycle, Carnot cycle, addition takes place at constant temperature, rejection takes place at constant temperature. This is isentropic compression, then isothermal heat addition, then expansion, isentropic expansion, then isothermal heat rejection. Here, the rejection is at constant temperature, but addition is at constant pressure. So that is going to cause the irreversibility because there is a temperature difference between the flue gas and the water. And due to the finite temperature difference between the flue gases and water, there are external irreversibilities in the boiler. Okay, so A kya ho jayega is the answer. Let's move to next question, question number 125. In steam power plant, what is the outcome of regenerative feed heating? Regenerative feed heating से क्या मिलता है बच्चों अपने को? क्या regenerative feed heating से steam power plant में work output बढ़ता है? No. With the regeneration, work output is not going to increase. Efficiency is going to increase. Work output तो घट जाता है बच्चों, efficiency बढ़ जाता है. क्वालिटी अनअफेक्टेड रहता है, कंडेंसर लोड कम हो जाता है बच्चों. With the regeneration, if you are extracting some stream from the turbine for increasing the mean temperature of the heat addition, or just to preheat the water before entering into the boiler, so you can carry out some regeneration. So regeneration से work तो घटता है बच्चों. With regeneration, work decreases, quality almost remains same, efficiency increases due to the increase in the mean temperature, condenser load decreases. Okay, B and D are the right, so C is the right answer. Let's move to 126th question. In case of diesel cycle, increasing cutoff ratio. You know guys, in case of diesel cycle, if you draw the cycle diagram, isentropic compression 1 to 2, then constant pressure heat addition, isentropic expansion, and then you will have constant volume heat rejection. So this is what a diesel cycle. So this is heat rejection, this is addition. So this ratio, the ratio of V3 by V2, this is known as cutoff ratio. This is a cutoff ratio. Guys, in diesel cycle, if cutoff ratio is increasing, if there is an increase in the cutoff ratio, the efficiency is going to decrease. The work output is going to increase. You can check it here. If you are increasing the cutoff ratio, guys, the net closed areas start increasing. With the increase in the cutoff ratio, the net closed area start increasing, guys. So if you are increasing the cutoff ratio, heat addition is going to increase, W net is going to increase. Okay, mean pressure, mean effective pressure is going to increase. Not the maximum pressure, guys. Maximum pressure nahi badega, because in a diesel cycle, the heat addition you are carrying out at constant pressure, so maximum pressure is not going to change, but the mean effective pressure is going to increase. Mean effective pressure क्या हो जाएगा आपका, बढ़ जाएगा. Mean effective pressure is going to increase, work net is going to increase, heat addition is going to increase, but the efficiency is going to decrease for higher cutoff ratio. So what will be the answer, guys? Efficiency, no. Mean effective pressure is the right answer. B क्या हो जाएगा आपका आंसर हो जाएगा बच्चों. With increase in cutoff ratio, the mean effective pressure is going to increase. Let us move to next question, question number 127. The COP of domestic refrigerator. What is the COP of domestic refrigerator, guys? The COP of domestic refrigerator is lower actually as compared to the air conditioner. Air conditioner, they will have efficient COP in the range of 3-4. 3-star air conditioner, you will have a COP close to 3. 5-star air conditioner, you will have COP in the range of 4.5. So air conditioners, they are having higher COP as compared to the domestic refrigerator. So domestic refrigerator, their COP is lower as compared to the air conditioner. Okay, air conditioner ka COP is in the range of 3 to 4. Usually refrigerator, it is having COP lesser. It is in the range of 1.52. So that is lesser as compared to the air conditioner. There is a assertion reason question. Question number 129 in front of you. Heat pump used for heating is definite advancement over simple electric heater. Is it right, guys? Heat pump is a advancement over heater? Yes. Yes. Because heat pump, for the same work input, like suppose if you are supplying some W input, it is going to supply some heat which is more than W. Okay. So heat pump is going to supply more heat. Whatever work you are supplying, it is going to supply more heat as compared to that. But if you are having a heater, guys, heater, so heater mein kya hoga? Maximum, whatever work you are supplying, that only is going to convert into heat. So maximum, max, ideal condition, ideal case, max to max, what we can have Q rejection is equal to W. This is the maximum case in case of heater. But in case of heat pump, the heat supplied, this is the heat supplied, this will be what? W plus Q1. So if you are having a 1 kilowatt heater, you are having a 1 kilowatt heat pump, the heat pump is going to supply more heat into the room as compared to 1 kilowatt heater. Or if you want to supply 1 kilowatt heat, then the work input required will be less than 1 kilowatt in case of heat pump, or work required in case of heater will be same 1 kilowatt. Okay, or it may be more than that. Ideally it will be 1 kilowatt. So if you want to supply 1 kilowatt heat in a room, you need to give lesser energy in case of heater. That's why heaters are more economical, their running cost is lesser. So that is a kind of advancement over simple electric heater. This point is right. The heat pump is far more economical. Yes, heat pumps, they are far more economical as compared to the electric heater, and that is the reason why we are saying this is an advancement over heater. So both are looking right and they are looking like connected. So we can go with option A. A and R, they are correct, and R is the correct explanation of A. A is the answer for this question. Let us move to next question, guys. Question number 129. Pelton wheel. Guys, different kind of turbine we use, like Pelton wheel, Francis turbine, Kaplan turbine we use. So Pelton wheel is suited for what? High head, low discharge, high head, high discharge, low head, low discharge, and medium head, medium discharge. Guys, Pelton wheel we use with high discharge, high head and low discharge. तो आंसर क्या हो जाएगा इसके लिए? High head and low discharge. Low head, high discharge we use for Kaplan. Okay, medium head, medium discharge we go with the Francis. Medium head, medium discharge Francis, Kaplan के लिए low head, high discharge, sorry. हाँ, low head, high discharge कर देता हूँ मैं यहाँ पे. Low head, high discharge. Okay, low head, high discharge. Kaplan, medium head, medium discharge, high head, low discharge. It will be a case of what? Pelton turbine, which is an impulse turbine. Match the following. Next question, question number 130. Question number 130 in front of you. Pelton wheel. What is Pelton wheel, guys? Now again, there is a related question. Pelton wheel क्या है? High head, low discharge. So low discharge, high head, Pelton wheel. What is Francis turbine, guys? Medium head, medium discharge. Kaplan turbine, it is low head, high discharge. So if you'll match with this, A is matching with the 4, B is matching with the 3, okay, C is matching with the 2. तो यहाँ 3 आएगा बच्चों, ये 3 आएगा. This is 3. This is 3. So D will be the answer. A4, B3, C2. Okay, A4, B3, C2. Please check. A is matching with 4, B is matching with the 3, C is matching with 2. So this D is the right answer. Next question move करते हैं. Question number 131. In reaction turbine, the draft tube is used. For what purpose we use draft tube, guys? For the safety of the turbine, to convert the kinetic energy of flow by a gradual expansion, to destroy undesirable eddies, to reduce viscosity of fluid. For what purpose we use reaction this draft tube? Yes, draft tube we use to convert the kinetic energy of flow by a gradual expansion. This is not provided for the safety of the turbine. Okay, so this is used to convert the kinetic energy of the flow by a gradual expansion. B is right. Which of the following is correct? In gas turbine with the regeneration, gas turbine में with the regeneration, what happens? With the regeneration, pressure ratio increases, work output decreases, heat input increases, thermal efficiency increases. So in Brayton cycle, gas turbine, we use Brayton cycle. So in Brayton cycle, if you're going with regeneration, that is going to increase the thermal efficiency, guys. Brayton cycle regeneration, the efficiency is going to increase. We go with regeneration in case of Brayton cycle to increase the thermal efficiency. So C is the answer for this question. Let us move to next question, 133. A turbine working on Brayton cycle produces 400 kilowatt of net power. Work ratio is 40. So how much is work ratio, guys? Work ratio is nothing but W net divided by W turbine. So how much is work ratio given? Work ratio is 40%, means 0.4. How much is W net? It is 4000 kilowatt. How much is W turbine? So W turbine will be 10,000 kilowatt. So W turbine 10,000 kilowatt. W net is this. What is W net, guys? W net is nothing but W turbine minus W compressor. So from that, easily you can conclude the W compressor is what? 6000 kilowatt. The W compressor is 6000 kilowatt. C is the right answer for this question. Which of the following pair represent the specific speed of turbine and pump? That only, directly you need to recall and you need to answer. What is the expression for the specific speed of turbine and pump, guys? So option 4 is the answer, guys. Specific speed of turbine and pump. Okay, थोड़ा सा इसमें mistake है and that mistake you need to correct. What is that mistake? So it must be what? It must be like that. NP 1 by 2. This is the specific speed of turbine, and this is NQ 1 by 2. So this is the right answer, guys. So there is a typing mistake actually in this question. Let us move to next question, question number 135. Adiabatic saturation for most air involves. What is adiabatic saturation, guys? It is a passing of the most air through a evaporative cooler. That is adiabatic saturation. What is this? Adiabatic saturation is a cooling and humidification process. Adiabatic saturation is the cooling and humidification process. So it is a kind of evaporative cooling. Adiabatic saturation is the evaporative cooling. Cooling and humidification. Question number 136 in front of you. If the specific heat of dry and water vapor, how much is the Cp of dry air? Dry air के लिए specific heat कितना है? 1. How much is the Cp of water vapor? That is 1.88 kilojoule per kg Kelvin. How much is humidity ratio, guys? Humidity ratio or specific humidity is given to you 0.001 kg per kg of dry air. So what is asking you? It's asking the specific heat of most air, guys. Guys, if you are having a mixture of most air and other gases, Cp of the mixture, specific heat of the mixture, you can write it as mass fraction Y1 Cp1 plus Y2 Cp2, where this Y1 and Y2 are the mass fraction, guys. Y1 and Y2 are the mass fraction. Okay, so this is the mass fraction. This is mass fraction. Okay, mass fraction of first, mass fraction of second. Now, if you want to define the Cp of mixture in terms of per kg of the dry air, let us define the Cp as the specific heat of the mixture per kg of the dry air. So Cp of the mixture, you can write like this. Cp mixture is nothing but what? Per kg of the dry air is nothing but, this is what? This is the dry air. So Cp of the dry air plus W into Cp of water vapor, guys. So if you divide both sides by the mass of dry air, you can write the specific heat of the mixture of dry air and water vapor as the specific heat of dry air plus W into specific heat of water vapor. So now if you will do like this, if you will use this expression here, the Cp of the mixture is equal to Cp of the dry air, which is nothing but 1 plus W. How much is W? This is 0.011 into Cp of the vapor, which is nothing but 1.88. So if you solve this, you will get the Cp of the mixture, guys. In general, this is the expression. This is the expression to get the Cp of the mixture, where this Y1 and Y2 represents the mass fraction. Y1 is the mass fraction of dry air. Y2 is the mass fraction of the water vapor in a most air. Most air is a mixture of dry air and water vapor. Now, if you will define the Cp of mixture per kg of the dry air, then dividing both sides by mass of the dry air, this fraction will be 1. This is the Cp of the dry air plus this will be what? Mass of the water vapor per kg of the dry air. So this becomes W and this is Cp of the water vapor. That's why I'm writing this formula like this. Cp of the mixture is Cp of the dry air plus W Cp of the water vapor. If you use this, you will get this. Okay. So this you need to multiply with this and very easily you can conclude the answer will be this, guys. Option A will be the answer for this question. Please try to answer this next question 137. For air with a relative humidity of 80%. What is relative humidity, guys? This is the ratio of the mass of the air to the mass of the air in the saturated air. Okay, maximum mass of the water vapor present in the saturated air. So if relative humidity is 100%, then the dpt, dew point temperature, dry bulb temperature, wbt, wet bulb temperature, all three will be same. Okay, now if relative humidity is less than 80%, what it means? Relative humidity less than 80% means the dry bulb temperature, because the air is not saturated. What it means? From that we can conclude air is not saturated. Air is not saturated. So if air is not saturated, in this case, the dry bulb temperature will be more than wet bulb temperature, and it will be more than dew point temperature. Okay. So for this case, what will be the answer, guys? The dpt is lesser than wbt. No, this is wrong. This is never going to happen. dbt will always be more than wbt. dbt can be equal to wbt if you are having the saturated air. dpt is less than wbt. Yes, this is right. For unsaturated air, dpt will be less than wbt. Dew point temperature will be less than wet bulb temperature. This case will be there only if you are having the saturated air. This case also you will have only if the saturated air. This is impossible. A is impossible. This you will have B and D, C and D if the air is saturated. But here the given condition is what? Relative humidity 80% means air is not saturated. That's why the answer will be what? dpt will be more than wbt. It will be more than dpt. So B is the answer. Let us move to next question, guys. 138. So you are having a cycle. On y-axis and x-axis you are having a cycle something like this. Now he's saying this is the air standard Otto cycle. Air standard Otto cycle mein how many processes we are having, guys? We are having 2 isentropic compression, 2 constant volume processes, something like this. So this is Otto cycle on PV diagram. Otto cycle on PV diagram. These are what? Isentropic. PV ki power gamma equal to constant. Isentropic. And these two are what? Constant volume. So now in this diagram you can clearly check. You are having horizontal and vertical lines only. It means definitely this plot will be for what? V and S. Velocity and entropy plot hoga bachon. Definitely this will be velocity and entropy plot because you are having 2 horizontal lines, 2 vertical lines. So this will be VS plot. Constant volume, isentropic, VS plot. Okay. Next question in front of you. Which gas power cycle consists of 4 processes in which work alone is transferred during 2 processes, heat alone is transferred during 2 processes? Very good question actually. ऐसा कौन सा cycle है? There are different thermodynamic cycle we are having, like Otto cycle, diesel cycle, Carnot cycle, which is actually not a practical cycle. That is a reversible cycle. So in which cycle, in 2 processes there will be work transfer and 2 processes there will be heat transfer. You know, guys, in Otto cycle, if you will draw Otto cycle PV diagram, if you will draw, so 1, 2, 3, 4. So this is PV diagram for Otto cycle, guys. In these 2 processes, this and this, there is no work transfer, but heat transfer is there. This is heat addition process. This is heat rejection process. In these 2 processes, there is no heat transfer, but work transfer is there. 3 to 4, you will get the positive work. 1 to 4, we will get the negative work, because here you will get the expansion, here this is the contraction. So Otto cycle is a cycle in which in 2 processes there is work transfer taking place. When work transfer taking place, there is no heat transfer, and in remaining 2 processes the heat transfer is taking place, and when heat transfer is taking place, there is no work transfer. So D kya ho jayega is the answer, guys. Let us move to next question, 140th question. The bore and stroke of the cylinder of a 6-cylinder engine. So आपको bore दिया बच्चों, D is what? 20 centimeter. The stroke length is what? 30 centimeter. And this is a 6-cylinder engine. कैसा engine है? This is a 6-cylinder engine. Total clearance volume. How much is the total clearance volume? This is 3000 pi centimeter cube. Okay. This is total clearance volume. What is the compression ratio, guys? What is compression ratio? It is a volume before compression, volume after compression, or it is a ratio of the total volume to the clearance volume. Compression ratio is the ratio of the total volume to the clearance volume. Okay. So guys, total volume क्या होता है? What is total volume? Total volume is nothing but swept volume plus clearance volume. Okay. How much is swept volume? Swept volume of a single cylinder. Single cylinder is pi by 4 d square into L. Swept volume, how much volume a piston is sweeping while moving from TDC to BDC, that is known as swept volume. So this is nothing but pi by 4 d square into L. So pi by 4 diameter, the bore is 20 centimeter into this is 30. So if you solve this, you will get, so this will be 400 divided by 4, it will be 100. So this will give you the 3000 pi. But guys, this is the swept volume of a single cylinder. This is the swept volume of one cylinder. How much will be the total swept volume? Total swept volume will be what? This will be number of cylinders into this. Okay. Total swept volume will be total number of cylinders 6 into the swept volume of one cylinder. So 18,000 pi is the total swept volume, and the clearance volume is 3,000 pi. So if you will write it here, 18,000 pi by 3,000 pi, so the compression ratio will come out 6. So B क्या हो जाएगा? आपका आंसर हो जाएगा बच्चों. Option B will be the answer for this question. So you need to check it here. Actually, this clearance ratio is the total clearance volume. This is the total clearance volume, the clearance volume of all the cylinders. Then swept volume also you need to take all. Otherwise, what you can do, because you are having a total 6 cylinder, you can find out the clearance ratio of one cylinder. So clearance ratio of one cylinder ka, it will be this divided by 6. So it will be 500 pi. Then you can take it as 3000 pi is the swept volume of one cylinder to the clearance volume of one cylinder. Then also you will get it 6. So what I want to tell you guys, if you are taking the total clearance volume, then you need to take the total swept volume also. If you are taking the swept volume of one cylinder, then clearance volume also you need to take for the one cylinder. Let us move to the next question. Question number 141. The efficiency of superheat Rankine cycle is higher than simple Rankine cycle. Yes. With the superheating, efficiency increases, guys. When we carry out superheating, the efficiency increases. Superheating से efficiency बढ़ जाता है, because with the superheating the mean temperature of heat addition increases. With the superheating the mean temperature of heat addition क्या हो जाता है? आपका बढ़ जाता है. So this is the plot for Rankine cycle, guys. So let me write it here. 1, so 1, 2, 3, 4, 5, 6. So this 6 to 1 is known as superheating process. This 6 to 1 is known as superheating. This is what? 4 to 1. This is kind of preheating process. 5 to 6 is the evaporation process. 6 to 1 is the superheating process. So superheating से क्या होता है? आपका quality of steam increases, mean temperature of heat addition increases, work output increases, efficiency increases. Okay. But there is a limit to superheating, because we cannot go beyond a maximum limit, because there are some kind of metallurgical limits are there. Most of the thermal power plant in India, they operate in the range of 550 degrees Celsius, even lower than that. So 500 to 600 is a maximum range. Most of the thermal power plant in India, they operate in the range of 500 degrees Celsius, 550 degrees Celsius. So superheating increases the efficiency due to the increase in mean temperature of heat addition. B is the answer for this question. Question number 142. Collapsibility of green sand. Collapsibility of green sand can be increased by adding. Guys, water से strength बढ़ता है, collapsibility क्या होगा? Initially it is going to, because it can increase also, decrease also. So water से strength पहले बढ़ेगा, much amount of water if you are adding, the strength will start decreasing. So collapsibility is not going to increase with water. Clay से, if you are adding clay or synthetic resin, then collapsibility is going to increase. Clay say and synthetic resin, the collapsibility is going to decrease because the strength is going to increase. If you are adding clay or synthetic resin in molding sand, then the collapsibility is going to decrease. But with the wood floor, the collapsibility is going to increase, guys. If you are adding wood floor in molding sand, then collapsibility is going to increase. So C is the answer, guys. Let us move to next question, 143. In a gravity feed system in casting, the cross-sectional area of the horizontal runner. The cross-sectional area of the horizontal runner. You know guys, what is the ideal shape of sprue? The sprue is having ideal shape parabolic, but we design it like a tapered section. Okay, tapered section we design just for the manufacturing difficulty, but the ideal shape of the sprue is parabolic. Ideal shape of the runner is trapezoidal, but what kind of shape we provide? Generally cylindrical. So the cross-sectional area of the runner is nothing but what remains same. It is not going to change. Sprue, right? आपका क्या करेगा? It will be something like this. Then you will have runner. Okay, so this is runner. Generally, we provide some kind of cylindrical shape. So the area is going to remain same. So A will be the answer. Next question, circular billet forging is a case of. Circular billet forging is a case of what? Plane stress, plane strain, unidirectional stress, unidirectional strain. That question, you can think, I will answer this question later stage. Circular billet forging is a case of what? Plane stress, plane strain, unidirectional stress, or unidirectional strain. I'm not very sure about the answer. Later stage I will discuss with you. Circular billet forging is a case of plane stress, plane strain, unidirectional stress, or unidirectional strain. Let us move to next question, guys. Question number 145. Work hardening exponent of any material can be calculated by calculating. How you can calculate the work hardening exponent? Work hardening exponent we can calculate by maximum true strain. Okay, you know guys, strain hardening component that is actually varies between 0 and 1. For metals it varies from 0.1 to 0.5. Strain hardening exponent, this is 0 to 1 in general, but for metals exponent this varies from 0.1 to 0.5. You know, there is a relationship, true stress is equal to K into true strain ki power n. So this is true stress, this is true stress, this is true strain, and this is strain hardening exponent. Okay, so now if you will check it here, this strain hardening exponent we can find out using maximum true strain. एक लाइन में आपको यहां लेके देता हूं. The strain hardening exponent actually tells us the ability of a material to get the strength when you carry out the strain hardening. So this work hardening exponent tells us about the ability of a material, to gain strength when we carry out strain hardening. When we carry out strain hardening. So how quickly a material is gaining the strength when you are carrying out the strain hardening, that is defined by its exponent. That exponent is known as strain hardening exponent. Okay, that is known as strain hardening exponent. Okay, that strain hardening exponent, ability of a material to gain the strength when we carry out strain hardening, that exponent n is usually having value in the range of 0 to 1, but for metals it is having value in the range of 0.1 to 0.5, and that you can find out by using maximum true strain. Let us move to next question, question number 146. Identify the wrong statement. If side cutting edge angle of a single point cutting tool increases, side cutting edge angle of a single point cutting tool increases, what will happen? Tool life increases, chip becomes thinner, chip becomes wider, temperature over rake face increases. Guys, if you are increasing the side cutting angle, that is not going to change what? that is not going to change the temperature over rake phase. So this statement is having no relation. Wrong statement. He is asking about the wrong statement. If you are going with the higher side cutting angle, so tool life increase karega, chip becomes thinner, chip becomes wider, but the temperature is having no relation with side cutting edge angle. Side temperature over rake face. Okay, so D will be the answer, guys. He is asking about the wrong statement. Okay, so temperature over rake faces will be unaffected if you are changing the side cutting edge angle. Question number 147. Identify the wrong statement related to the back rake angle in single point cutting tool. Back rake angle in single point cutting tool. Increase in back rake angle is going to change what? आपको wrong statement निकालना है बच्चों. Back rake angle, increase in back rake angle. Yes, increase in back rake angle is going to increase the tool life initially. Contact length of the rake face will decrease. Cutting forces are also relatively, they will be decreased. But lip angle, this is a wrong statement, guys. Lip angle increases, this is the wrong statement for this question. Let us move to next question, question number 148. Increase in semi-die angle in case of metal forming. The die life. Guys, let me draw it here, a case. Suppose we are having a die like this. We are having a die like this. So let me here take a die, something like this. Okay. So this is the die angle, something like this. So there are two cases actually. There are two cases. So this is what, this is the first case. Second case may be like this. Second case you can take like this. You can take like this, where the die angle is like this, more steeper, something like this. Okay, so this is the die, guys. This is what, this is die. This is die. Now try to think in these two cases, the die angle you are increasing. Okay, this is what, this is a case of lower die angle. This is a case of lower die angle. And this is the case of higher die angle. Higher die angle. Guys, when you are going with higher die angle, the die life, because the strength of the die is going to reduce. When you are going with the lower die angle, the strength will be more. Lower die angle से क्या होगा बच्चों? Strength will be more, but the friction will also be more. Lower die angle से strength higher, friction higher, and due to frictional, the force required, force will also be higher. So when you are going with the high die angle, the strength will be more, the strength of the die will be more, friction will be more, because more length of the die is coming in contact with the material, guys. More surface contact. Here, the friction will be less. Higher die angle, strength will be less. Strength will be less. Frictional will also be less. Okay, and in general, what you can say, force will also be less. So what is asking you? Increase in semi die angle. Increase in semi die angle. If you are going with this to this case, if you are increasing the semi die angle, what will happen? The die life is going to what? The die life is going to decrease. Okay. So I feel the best answer for this question will be decrease, guys. Okay. Increase in semi die angle is going to decrease the die life. Okay. That is going to decrease the die life. Please check, because when the die angle is lower, the friction will be more, strength will be high. But if you are decreasing the die angle, strength is going to decrease, frictional is also going to decrease. Let us move to next question, question number 149. So 2 क्वेश्चन मैंने आपको आंसर नहीं किए. I think this is question number 149 and one more question I have not answered, which is 144. So that separately we will discuss. 144 and 149. So this also, this time I'm not answering. We'll check. Dead metal zone forms in extrusion process because. Let us move to next question. Maximum reduction can be given to any material in what kind of rolling mill? Maximum reduction can be given to any material in what kind of rolling mill? In what kind of rolling mill, guys, we can get maximum reduction? You know, guys, there is a mill which is known as a planetary mill, which is having lots of a large size backup roll, and there are so many planetary mills we are having. Okay, so this kind of arrangement. So in planetary mill, in the single pass only, we will get the maximum reduction. So guys, if you are having a planetary mill, something like this, then in the single pass only, we will get the maximum reduction, guys. In single pass, the maximum reduction is possible in a planetary mill, guys. So answer for this question will be A. 3 high mill, 4 high mill. Yes, the reduction in 4 high mill will be better as compared to the 3 high mill, but the reduction in single pass will be maximum in case of planetary mill. So for this case, the answer will be A, planetary mill. Okay, so guys, these are the 150 questions we solved, we discussed in the today's session. I hope these are clear to you. Time was less actually, because initially, we cannot go into much more theory part. I hope you can get idea, because here 150 question, if you want to target 150 question, if you want to target in a time of this 3 hour or 350 minutes, 3.5 hour, then it is very difficult to cover the theory part, guys. I tried the all related part, whatever minimum we can cover, that I tried to cover. But yes, we are having regular theory classes for covering the entire theory part. Okay, and in all those regular classes, we are covering that theory part also. But when we are covering these kind of sessions like 150 or 100 questions we are covering, we cannot spend much time in discussing the theory part. Okay, so some direct factual information you need to remember, like some of the cases, like we discussed from vibrations from theory of machines. So there are some outcomes, some results which you need to directly remember. Okay, like the Corolli's component of acceleration, the Weir theory. Okay, and some cases we discussed related to the vibration. So those important cases you need to remember if you want to solve these kind of 150 questions, because in this paper actually you are having 150 minutes 150 times, 150 minutes only, and 150 questions are there. So in less than a minute you need to answer a question. So that's why you cannot spend much time in actually deriving a particular relation. That much time you are not having in your final exam. That's why some important results you need to remember. Okay, so keeping in mind, wherever we can remember that important results, I directly click that particular answer. I hope you can understand there is a limit. But yes, whatever part which you can which you cannot remember directly, or you can derive, that I try to derive it here in front of you. Okay, further, if any suggestion, any query if you are having, you can shoot your query in the comment section, and surely we will consider all your queries. Surely we will do like that. We'll try. Okay, we'll try, because this is first time actually, because it is difficult, because there are some different areas. Generally, there are different experts. Usually a teacher cover a particular subject only. Okay, like suppose, because most of the time I teach here thermodynamics, heat transfer only, most of the time, then for a teacher it is actually very difficult to pick different question and then just to take all those different concepts in detail. Okay, that's why there is a limitation, but we will try. And yes, that can be a good idea, because when we are covering more than 100 or 150 questions, then yes, we are revising the entire subjects. So if you will go for suppose 50 or 100 questions, 50 or 100 paper, just imagine how much number of questions you will be able to practice. So if one paper there are 150 questions, and suppose you are practicing 50 papers, daily or after 2-3 days you are practicing a paper, then just imagine the number of questions. And surely in any of the state level or PSU questions, actually they ask repeated question. They're not going to frame new question. 5-10% there may be chances they are framing some new questions, but most of the time actually it is observed they pick question from engineering services, SSC, state level, or any other competitive examination. Okay, so that's why practicing more and more questions from various different competitive examination is a good idea. Okay, that's why we came up with like that. Again, you need to practice some more questions. So any doubt, any query if you're having, you can shoot in the comment section. Thank you, good night, and keep preparing. Okay, so this paper I found related to Telangana State Public Service Commission, and I sold this in front of you. Thank you, keep enjoying the session. Thank you, good luck.